So good morning, guys. First, let me welcome all of you on behalf of SunBeam, and then we'll start with this new course on Python. Now, before we start with the Python, let me give an idea about it. If you have seen in today's industry, AI is playing a very important role. ML, you must have heard about this, machine learning, AI, agentic AI, and all of this, which are related to artificial intelligence, is really playing a important role in today's industry, and that's the reason why we have designed this course. Now, you may ask the question like, what's the the interconnection or what's the relation between this course and AI or ML there? So actually, if you have heard about this ML and AI, which is again, as I said, it's really in boom, the development of this AI ML is done mostly in Python. Now, why Python? By end of the day today, you will understand that answer also. But right now, just to give you a context of it, Python is most versatile language. Now, when I say versatile, versatile means it can be used in multiple different domains with multiple different use cases. Like for example, Python can be used for developing AI ML application, which is why we are learning here today. It could be used for developing console applications. It could be used for developing GUI applications. PyTK, there's a package available there. You can also go for developing the REST web services, which will be developed in the course also. We can use it for data exploration, like NumPy Pandas. It can be used for visualization, something like the Matplotlib, Seaborn. And there are hundreds of use cases where Python is used there. And that is the reason Python is one of the most lovable, simplest, and famous language in today's world. That's why people are learning Python. I believe this is one of the requirements for you also, and that's the reason you are joining this course. Our intention for Python is very simple. We want to learn AI, ML, data exploration, precisely the data science. This is what our goal here would be. And to achieve that goal, we are learning Python. Python is a general purpose language. I'll explain what do you mean by general purpose language in a minute, but it's a general purpose language. Anyone can learn Python. It's need not to be like you have to go with the data science and then you have to learn Python. You can learn Python and do a lot of other things. Even testers use Python as a default language because it's the simplest language, and testers use it for automation, test automation. So there are multiple use cases. There are hundreds of use cases where Python is very famous, and that's why we started this course. Okay. Now, before we start with the course and before I introduce myself, let me first introduce to the entire contents of this course. I mean, what exactly are we going to see there? So you can get an idea, fair idea. Like if you are kind of looking for something else, or if you say like, okay, we are not looking for this or we are looking for this, you can set your goal and then you decide whether you opt for the course or whether you want to go for something else. Okay. So this is what we are going to cover, and there are many. I'll explain one by one, but there are many things that we should look for. Now, the first thing, I mean, the first step we are going to start with is we'll get ourselves introduced with the Python. So we'll understand like what's the Python, where it is used, why Python, or how Python, so on and so forth. So we'll start with the Python, but we'll not start with the Python as a language. We'll start with the language. So I'll start today with something called as the language fundamentals. And when I say language fundamentals, we'll start with what exactly the language here is. I know most of you are kind of starting Python as your first language. So we'll start with the fundamental of, not functional, it's called the language fundamentals. When I say fundamentals, we will start with what exactly do you mean by language? We'll start from there. Where language is required, what kind of languages are there, like general purpose languages or assembly language, machine language, so on and so forth. So we'll start with that. Then we'll start talking about what exactly the Python here is. We'll understand today, end of the day, what exactly the PVM here is, which is the most important stuff in the Python, called as a Python virtual machine. What do you mean by compiler? What do you mean by interpreter? And so on and so forth. I mean, how the interpreter and compilers are playing important role in Python. I mean, whether the Python is a compiled or interpreter, you'll be able to answer that question today itself. This is called an interpreter. So this is what we'll be doing today. It's called an interpreter. So we'll start looking at this all stuff today itself. We'll get ourselves introduced to the Python. Now, to introduce our Python, we have to start writing the code as well. In a sense, like we have to write line 100, not 100, even thousands lines of code throughout this course. For this, you have to configure your environment. Now, I know most of you already have heard about environment here is, but what exactly it is? So, environment means your machine, which is used for developing the Python application. So basically, we'll understand what different things are required on your machine. So basically, we are kind of going to install all the Python required versions on your machine. So today or maybe max tomorrow, I'll talk about the installation. I'll talk about something called as a Python package manager. Just give me a second. Seems like Just a sec. This is why it is giving me a trouble writing it. Okay. So let me just go back and turn it off. Yes. Huh. So I was talking about something as an interpretation, sorry, installation. And when we are going for installing, we'll be also getting ourselves introduced with something called as Python Package Manager. There are many. I'll talk about them a little bit later in details also, but today I'll just introduce, today or tomorrow, I'll just introduce what do you mean by package manager and how it is going to help you to install all the packages later. There are multiple package managers. There is something as a pip, which is by default available on your machine. There is a UV, there's a Conda, and there are many others. I'll talk about all of them in detail later when we start talking about something like the modules and packages. At that time, I'll introduce them in a details way. But right now, today or tomorrow, I'll just give you an idea about what exactly you should install on your machine so that you can use your environment, you can use your machine in order to develop the applications using Python. So this is the environment configuration. Okay. Now, once our environment gets configured, we'll start writing the code. And precisely when you start writing the code, the very first thing in any language, be it Python, C, C++, or any other languages, you start with something called a data types. Now, again, we'll talk about all of these details, all of this stuff in detail later, step by step, one by one. But just to give you a context of it, a data type means a type of data. Like when you start developing the applications using any of the languages, you will start creating something called as variables. When you create a variable, you want to store some value inside it. A variable is a memory where we want to change the values continuously whenever there is a requirement. These are called the variables. Now, every variable will tell you what kind of value it can store, and this is given by something called as a data types. There are 5 data types, precisely 5 categories of data types in Python. I'll explain all of them later. Just to give you a context, there's a numbers which contains integer, float, again something like complex as well. Then there is something called as a string. There is something as a collection. There is something collection in a sense like something called as a list, and there are multiple others like something as a dictionary, something called as a map. There are multiple options available out there. All of these are data types which are given by Python, which are by default supported. Whenever you are going to require to declare the variables, you need to also say what kind of values you want to store there. Good thing is in Python, again, we'll see all of them in details, but good thing in Python, this is called as a dynamically typed language, meaning you do not have to bother about setting the variable's data type. This is called as dynamically typed language. So when you are declaring a variable, you just have to say a variable name and it's a value. It will automatically tell you what kind of data type that variable is going to have. And this is what Python says. It's a dynamically typed language. So again, we start ourselves getting introduced to the Python. We'll configure our environment, and once it is configured by end of the day today or max by tomorrow, we'll start with the language fundamentals where we'll start with the data types. Now, once we understand how to declare the variables, what data types are available here, so on and so forth, we start performing some operations on them. And to perform the operations, every language will give you set of operators. Now, when I say set of operators, there are different categories of operators. One of them could be something like mathematical operators, or they are also known as arithmetic operation. Arithmetic means those are simple like addition, subtraction, multiplication, division, so on and so forth. Those are arithmetic operators, and they are fundamentals one. Whenever you are developing an application, you will perform the operations on your variables by using those arithmetic operators. Then there is a comparison operators. When you say comparison operators, you want to check the values whether they are greater than, less than equals to, greater than equals to, not equals to, so on and so forth. There are comparison operators. Then comes logical operators. Logical means and or, precisely and or and not or nor it is called as, which means whenever we are going for something like the conditions like this and that or this or that, so these logical conditions will be performed by using the logical operators. And there is something called the bitwise operators. Again, a little bit important from your interview point of view, which will be generally asked in interviews, like what is a bitwise, bitwise and, bitwise or, bitwise XOR, so on and so forth. So there are 4 major categories: arithmetic operators, comparison operators, logical operators, and bitwise operators. We'll see all of them in details. I think in this week only we'll cover that part, operators. So this will give you a chance to perform operations on the variables that you declared earlier. So precisely, you declare the variables and you perform all the operations by using those operators. Now, while performing the operations, you would need some kind of conditions to be executed. Like for example, someone is asking me, like my age is something like a 14. Now, am I eligible for something like a voting in this country? Now, what would I say? If my age is above 18, greater than or equals to 18, then I'm allowed. Otherwise, I will not allow for voting. This means there are multiple times we want to check the conditions and get certain piece of code executed. This conditional execution comes under something called a control flow. There are multiple types of control flow statements. One of them, which I mentioned just now, it's called as an if else. It is known as, it's like if else. Then there is something called as a for. This is called a for in loop in case of Python. Then there is a while loop in Python. Again, very much different than from the other languages. There is another condition, something called as a for else condition or for else loop, while else loop, and so on and so forth. So there are multiple different type of control flow elements, control flow statements. We'll look at them later. You know, so this is where we will get an understanding of how you can perform certain conditions in Python. These are called as control flow elements or control flow statements. Then other than that, there is something like a break and so on and so forth. So precisely this will give an idea, like if you are performing some conditions, sometimes you don't want to execute something, you can say break. And again, all of these things will explain in details when we go for that topic. Just giving an idea like what things we are going to cover in this particular course. So once you understand how to write the if-else condition, for loop, while loop, so on and so forth, we'll go for the major and very important topic called as the functions. Now in Python, functions are considered to be the first class citizens. What do you mean by first class citizens? Generally, I mean, not other languages, but generally, Python like languages, Python, JavaScript, Swift, all of these are kind of something known as the functional programming languages. I'll explain what do you mean by functional programming in a second. But in such languages, functions are considered as a top priority. Why? I'll explain that later. But consider this. In Python, function is considered to be the first class citizen. And that's the reason it's a very important topic in Python. There are multiple things we will learn about the functions in this particular topic. Like for example, we'll go for how the functions are created. Those are known as something like the function references. A very important topic and very complicated topic, and precisely it is used a lot in multiple different scenarios, in multiple different other modules as well. These are called the function references. Again, it requires some internal understanding of how the functions are created, but again, they are the function references. Next, we will understand what kind of functions can be written in Python. Something called as named functions and something called as unnamed functions. Unnamed functions here are known as lambda functions. Another important topic for your interviews. What do you mean by lambda? How lambda can be written? What are the rules lambda will need to follow when we want to write them? So again, there are multiple interview questions I'll share later, and I'll discuss them as and when we go for that particular topic. So every topic will explain or will discuss all the interview related stuff, interview related preparations when you want to go for performing those, or maybe when you are going to appear for the interviews for different companies. Okay, I'll mention all of them later. So I was talking about the functions here. So function references, lambda functions, again, internal functions or external functions or user-defined functions. There are multiple different things we'll understand here in the functions. And function, as I mentioned, it's a very important topic in all languages, including Python. In Python, it is very important because in Python, as I said last time, function is considered as a first class citizen. It's called as first class citizen. I mean, in short, what I can say here is why is it called a first class citizen is because in Python, when you are declaring a variable can also be declared as of type functions. That's why it is important one and generally asked in interviews. Like, what do you mean by function references and why it is known as a first class citizen? I mean, what's the advantage of being considered as a first class citizen? This kind of questions you will be seeing in your interviews. I'll explain them later. I'll put the examples also for you to understand this topic clearly. And this is the fundamental topic in every language, including Python. Now, once you understand function, this is the very basic bare bone or basic building block of a Python. We'll start with another important topic called the collection. I mean, every language has collections. Python has four types of collections. including, or rather starting with the simplest one called as a list. Then there is something called a tuple. Few people pronounce it as a tuple as well. So tuple or tuple, whatever you want to pronounce it as, that's okay. List, tuple. Then there is something called as a set. Set means it's like collection of unique values. You probably have heard about them in your school as well, like union, something like intersection, so on and so forth. That's the same set. We will be learning later. And finally, there is something called as a dictionary. So precisely, there are four types of collections. Collection means instead of declaring multiple variables to store multiple values, we declare a single variable and we store multiple values in that variable. That is called the collections. In simple languages like C or not simple, but in simple terms, they are nothing but the arrays. Here there is no array. Here we start with the list or tuple or set or dictionary. Another important point for your interviews. Like what's the difference between list and tuple, or what's the difference between list and set, what's the difference between list, tuple, set and dictionary, so on and so forth. So these are the most fundamental collections available in terms of Python. Okay, there are four, as I mentioned: list, tuple, set and dictionary. Okay, now once you understand the collection, we'll start with another important interview favorite topic: functional programming. I mean, what do you mean by functional programming? What exactly the functional programming gives you, or what are the advantages of it? We'll understand all of them there. There are majorly three properties of any language to be considered as a functional programming. Number one is, as I mentioned last time, a function is considered to be a first class citizen. This is the fundamental requirement of any functional programming language. JavaScript is a functional programming language. Python is a functional programming language. Swift is a functional programming language. Kotlin is a functional programming language. All of them consider function as a first class citizen. Means you can declare a variable of type function. Another important requirement of a language being a functional programming is like you can pass one function as a parameter to another function. Pretty surprising, but yes, you can pass one function as a parameter to another function. And last one, the requirement of a functional programming here is you can return one function as a return value of another function. I'll explain all of them in details later. And this is, as I mentioned, interview favorite topic, functional programming languages. These are very important functions in Python which are used very frequently. One of them is called as a map. Another one is called as a reduce. Another one is called as a filter. Another one, and there are many others. We will create our custom functions as well. But these are the fundamental ones which will help you to understand how you can use this concept, functional programming, to solve many different problems which can be written in a simpler syntax: map, filter, and reduce. This also give you something called as a list comprehension. I'll write comprehension right now. Comprehension. So there are three types of comprehensions possible in terms of Python. It's something called as a list comprehension, a tuple comprehension, and a dictionary comprehension. Again, this is another simpler syntax available in Python, which will solve the problems of map and filter together. More on that later. But this is another interview favorite topic. What is a comprehension and what exactly the advantages of comprehension over map and filter? Again, we'll discuss them later in details. So there is a map, there is a filter, there is a reduce, and there is comprehension. All of them belong to the same topic, functional programming. Okay. This will be, maybe you can say, the reason why I said the function is very important topic in Python. Okay. Now, once you understand functional programming, we'll start using something called the file IO. File IO means you want to open a file, you want to save a file, save the contents in the file, or you want to read the file contents, or you want to copy the file contents from one to another, you want to move a file from here to there. So there are so many operations we can perform on the files. So this is something like a file IO. File input output means like reading or writing the contents in the file. And this becomes a very important point when you go for some advanced use cases of Python. Like for example, you want to go for machine learning, and in that case you want to read the contents from a file like CSV file. To read the contents from that file to store that data in your variable, a file IO is required. Tomorrow you created a model and you want to store that model so that you can launch it in the production. You can save that file, or you can save that contents of the model in a file. That again requires you to understand file IO. So file IO is very importantly used in day-to-day environment or day-to-day use cases of Python. So that's a file IO. Another interviewer favorite topic is something called an object-oriented programming. And I can bet on this, when you go for Python interview, you will get dozens of questions on this. Dozens of questions. The important thing about the OOP in Python is like it is completely different than C++ or Java. I mean the traditional OOP here. Generally, when you go for traditional OOP, you have to write the classes, and once the classes are created, you can't modify those when you are generally creating the objects of those classes. Python breaks that rule. In Python, you don't even have to write anything in the class. You can just create an empty class and keep adding the objects and keep adding the values inside the object, because this is dynamically typed language. This will give you a flexibility to update the object memory without modifying the class. This is the fundamental requirement or fundamental property of OOP in Python. That's why interviewers like to ask questions on OOP. It's totally different compared to the traditional OOP there, and that's the reason you should understand how the OOP system or how the OOP concepts are implemented here in Python. Most importantly, we'll start with something like a class, because this is where you want to create an object from. We'll talk about the object, and then we'll talk about all the jargons in OOP like encapsulation or abstraction or polymorphism, so on and so forth. It's called as encapsulation. Then we'll go for abstraction, and again all of them are important ones from your interview perspective. Abstraction or polymorphism. Then there are many others, like for example we can go for overriding, overloading, and there are many other options available in OOP. OOP is another important thing from machine learning's point of view as well. So tomorrow if you want to use Python for, let's say, developing the AI applications by using something like a deep learning where the PyTorch or TensorFlow will be used, there you have no option but to write the class. So you have to know what do you mean by class, how to write the class, how to write the members inside this, and there are multiple different things available there. And all of them, as I mentioned, are interview important questions, interview important topics inside OOP. So that's what we are going to learn here in the OOP part. Now, I would say till this, or including this one also, something called an error handling. Error handling means whenever you are writing the code, most often you will write the code fine. I mean, there is no problem with that. But you never know like what user is going to put the input, and based on that input, your program might crash. For example, if I wrote an example like this, say I want to get a result, I want to get a result like this. Result which is going to be equals to num divided by something like, or maybe I can say 10 divided by num. That's a better example. So when I say 10 divided by num, if user enters, let's say 2, I say 10 divided by 2 is going to be equals to 5. Everything will work fine. There's no problem with that. But tomorrow, if user enters num equals to 0, probably you can understand you cannot divide any number by 0, because that will produce infinity. So this application will definitely crash in any language for that case. So in Python also, this program will crash when the num becomes 0. So to handle such kind of runtime failures, we are having a topic called as error handling, another important topic in Python. Error handling. How will you save your application from crashing in such cases where you have not anticipated it before? In a sense, I didn't expect user to enter num equals to 0, but I know user will enter it. Users are crazy, or users are idiot for that case. They might enter anything here, and in which case I don't want my program to crash. In such scenarios, I will handle these scenarios by implementing a concept of error handling, which will require you to use the keywords like something called the try, or something like a catch, or I'm sorry, there is no catch, there is except here. So try, except, something like maybe finally, so on and so forth. Or you can say raise, and surprisingly else. So there are multiple keywords which are used here in terms of handling the errors, so that you can save your application from crashing in the scenarios like you have not anticipated before. This is called an error handling. And for error handling, you have to understand OOP, because error handling requires you to create an object of an exception class. And that's the reason why we'll first cover the topic OOP and then we'll go for error handling. So again, that's important topic of Python. Now, I would say from here to here, so from here to here, I can say Python will get completed. In a sense, whatever you need to understand in Python will kind of finish somewhere here, error handling, till error handling. Out of that, from here to here, we can say the simple Python, or you can say the basic Python. From here to here, this is, sorry, here to here, this is little bit advanced Python. Now, till error handling, we are going to finish the Python. That's what the Python as a language you can understand or you have to understand. Okay. Now, after this, what we are going to do? Python is very famous, not because Python as a language is used multiple times in different scenarios, but Python has provided not hundreds and thousands. I think there are more than 300,000, means 3 lakh packages available in Python. And those packages will make Python one of the famous languages in today's industry. So this is a very important concept again in Python, which will give an understanding of how to reuse your code. So if I have written my code and I don't want to write the same code again and again, I want to share my code with others. This is the fundamental job of modules here is. So it will reuse the code. This is why the modules are used. And there are, as I mentioned, more than 300,000 packages available in Python. This will give you a functionality like I can use a Python for testing, I can use Python for data science, I can use it for visualization, I can use it for AI ML, I can use it for n number of cases out there, n number of cases. So we'll understand how to reuse the code by using the modules. So this is what we will understand. A module is a simple Python file which can be used or which can be reused later in other Python files. And packages are nothing but the collection of different modules. This is called the packages. And there are more than, as I mentioned, more than 300,000 such packages. 300,000, more than that. 300,000 is an old number. I think it is increased to around 500,000 applications available there, 500,000 packages available in Python. And those packages will make the Python so rich, it can be used in multiple different scenarios. Generally, Python is considered as a toy without batteries. Toy without batteries means, let's say you purchase a toy which requires a battery, and if I do not put the batteries inside the toy becomes literally useless. I can't play with that toy because it can't function itself because there is no battery. Something similar happens in Python. Python is considered as a toy without a battery. So if I want to make that toy functional, I have to put the batteries in. Those batteries are nothing but the packages. So there are more than 300,000 such batteries or packages available, which will make Python one of the most lovable, as I mentioned last time, one of the most lovable and one of the most famous languages in today's industry. So there are more than 300,000 packages out there. And few of such packages, important packages, we are going to learn here in the course. Starting with one of the most fundamentals, and this is again expected in interviews, data handling packages, which starts with something called as a NumPy, one of the very famous packages in Python. As a Python, even if you're not going in data science, as a Python developer, I have to understand NumPy because NumPy will give you a better one, memory managed, and better second, efficient collection compared to what Python provides here as list, tuple, set, and dictionary. So these are default collections, but they are very slow. Why are they slow? We'll talk about that later in the collections topic. But right now, as you can see here, in data handling, if I want to handle a huge amount of data, I have no option but to go for NumPy. Along with the NumPy, we also will go for something called as a Pandas. This is again a very fundamental one that will give you an understanding of how to read the files or how to read the data from different files like CSV files, JSON files, Excel files, HTML files, and so on and so forth. So there are many different formats Pandas supports, and both NumPy and Pandas are considered to be the fundamental packages of Python. Without them, many of the applications would not work. And there are many other packages which are developed on top of NumPy and Pandas, not Pandas, but NumPy precisely. Pandas also is developed on top of NumPy. There are many other packages. If you are going in machine learning or AI/ML, all packages of AI/ML are developed on top of NumPy. You get any of these examples and they will require you to understand NumPy. Most of them will also require you to understand the Pandas as well. And that's why both of them are very important in any context, So these are common denominators of all the different use cases, all the different scenarios where the Python is used. And that's why we'll focus on this. I'll give you much deeper understanding of NumPy and Pandas, and both of them are important from your interview perspective as well. Today's industry require you to understand Python for AI/ML a lot, and in that case, NumPy and Pandas are playing very important roles. So NumPy and Pandas will be used there. Now, a data which you are going to read in NumPy and Pandas can be stored or can be read from the files most of the times. But what if I want to permanently store my data, let's say in database? How do I do that? This is where we'll understand database connectivity. We will not go with the databases. I mean, we will not understand what is MySQL or what is MongoDB or something like the other databases out there. But I'm assuming that you must have at least heard about something like a MySQL or something like a MongoDB. Even if you have not heard, I'll just give you a quick brush up of all the databases there. We'll consider at least two databases. One from RDBMS point of view, which is very commonly used as MySQL, or MySQL it is known as, and another one is something called as a NoSQL category, which is very famous, called as a Mongo. So I'll give you understanding of how both of these how both of these databases can be connected to the Python application. So tomorrow, if you want to get the input from user and if you want to persist the data in one of the databases, how do you do that? This is what we'll talk about, the database connectivity there. Wonderful. Then comes another important topic called as a web services. And again, in today's industry, if you are developing the applications, I mean, real world application I'm talking about, let's say mobile applications or let's say web applications, they will not do direct database connection. They will instead talk to something called as a web services, which will be developing in terms of something called as a REST, representational state transfer, it is known as REST. I'll try to introduce something called as a GraphQL as well, which is a kind of, in today's industry, a standard one, because GraphQL is developed on top of REST, and that's why they are kind of used for something like connecting to databases. Another important topic. Uh, Another one in web services itself, will try to get the web services in two-way connection by using something called the socket.io precisely. So that's another important package we will be using in web services development. And probably, again, it's not required to be honest, but I'll go for both of these packages here. For developing the REST APIs, we'll go for something called a fast API. Both of them are important. One of them is called as a fast API, and another one is something called a Flask. So precisely we'll be using those packages there, something like the fast API, something like the the Flask, fast API, socket.io, and GraphQL. So these are different packages that we'll be using for developing the three-tier application: GUI application or console application, the backend application called as a web services, and a database connectivity application, which will help us to store our data permanently. So this is the real world understanding of how the applications can be developed in Python. Okay, now other than that, in data handling, there is another important point, something called a visualization. So data handling means handling the data or reading the data. But once you handle the data, you want to analyze the data, and for analysis, we want to visualize the data. Visualize means we want to convert the data into something like the charts or graphs, for example. For this, we'll be learning a package called as matplotlib, it is known as, and it's a very important package as well. Other than that, we'll be using something called as a plotly. This is also a very simple one written on top of matplotlib. And there's another one, something called as a Seaborn. Again, all of these packages are by default used in all AML applications. And that's the reason why they are important ones and why we want to learn them here. So in data handling, we'll be loading the data by using NumPy and Pandas. At the same time, we visualize the data by using matplotlib, plotly, and Seaborn. So they're the package that we'll be developing. Now, other than this, I think I'll mention kind of another packages here. Other than that, we'll be using something called as a Selenium as well. Selenium is mainly used for testing. I'll give you what you mean by testing here. And it is also used for something called as a web scraping. Another important topic for data science people, those who want to or those who are willing to go in AI ML, they have to first grab the data. They have to first scrape the data from different websites. So this is called a web scraping. This is both. I mean, the Selenium is used in both the cases, used in testing also, and it is also it's also used in web scraping as well. Okay. Other than Selenium, there is something called a PyTest. I'll give you an idea about this. This is also used for testing. End-to-end testing, we can call it as. So PyTest and Selenium, both of them are used in testing. Selenium is used for web scraping as well. For web scraping, there's another one which is very famous, and we'll be looking at that example as well. Something called as a beautiful soup. It's called as a beautiful soup. So this beautiful soup and Selenium, both of them are very famous in terms of web scraping. Web scraping means getting the data or scratching the data by using something like understanding the HTML contents of it. So that's what we'll be learning. you know. Yes, someone is talking about that. For testing, will go for something called a playwright. That is end-to-end test. I mean, actually, it's UI testing, to be honest. So there's like an automation we can go for, testing automation. That's called the playwright. And again, we can go for it precisely. You can say, sorry, we can go for it and say how we can automate our testing by using the playwright. There are many different modules available there. These the important models will be kind of looking at it. And believe me or not, all of these models are used in real world applications. Like for example, this is like the fundamentals ones, as I mentioned. These are used for visualizations. These are used for connecting databases. These are used for developing the web services. These are used for web scraping and so on and so forth. So there are more than 300,000 packages. It's not possible for us to cover all of them, but these are the basic ones that we'll be developing. Other than that, we'll be talking about some system, or you can say the default packages as well, or default models we can call them as. Default means which are provided by Python. Default packages. One of them is something called an OS, an important one, because this will give you an understanding of how do I move the files, how do I get the contents of a directory, how do I, perform some automation on top of file system, so on and so forth. Then there is something called the JSON, another important one, which is used for performing all the operations on the JSON. Both of them are important one. Then there is something called the sys, stands for system, and there are many others. We'll see each one of them one by one in details. So all in all, you see there are many packages that will be focusing on, and because of these packages, Python has kind of considered as a very famous language in today's world. Guys, may I know if you all there and you are getting the points, like what things are we covering here? Do you have any question to ask? If you have any question to ask, please put the question here on the chat, or you can definitely unmute yourself and ask the question. No problem. Okay, I can see some.
Sir,
Yes, please go ahead. Shruti?
so this course will be focused more on the ML side or on the back as a backend developer or for the backend purpose. What should be the goal here?
Okay, very good question. What's the goal here? My goal here is to understand, I mean, you need to understand Python, which can be used in variety of reason, variety of different use cases. My focus at this point is you should go for something like a data science, ML, or AI, but that does not stop you from learning Python to go for web services, because I included web services also. If you want to develop a backend application, you need to understand like how do we develop the REST application, how do I develop the GraphQL application, socket UI applications. I have covered all of them here as well. So I don't find any problem if I want to learn Python for web services in this course. So all these use cases, general use cases, have been covered. If you want to be a tester, you have to understand Selenium. So I'll cover one entire session talking about how to write the test cases and how to execute the test cases or automate the test cases by using Selenium. Playwright also by using a PyTest. So that will give an understanding of how you can make your career, how do you pursue your career in terms of testing using Python. If you are going for pursuing your career in web services, these are the packages which are very famous. If you are going for something like the data science, they are the packages you have to focus on. So most of the packages which are used commonly in other, almost all different type of scenarios, I'm trying to cover here. Shruti, does that answer your question?
Yes, yes.
Very good. Who's that? Divyansh, what topics I need to focus on if I'm going for PGCP BDA? Okay, if you are opting for BDA course, Divyansh, in which case all of them are important, all of them. Rather, you can consider this as your prerequisite of PGDBA, or in case of PGDBA, whenever you are going for something like machine learning, we'll be using or we'll be considering a machine learning developer knows all of that stuff. Without this, you cannot opt for BDA. I mean, you can't complete the BDA. I don't say you will not opt for it, but if you are going for BDA, then you will definitely will require everything in Python. There is nothing you are going to skip here. Okay. Fine. I think you must have got an idea like what things we are going to cover here. I gave you a brief understanding of it. Now, before we start with the actual contents or actual course, let me quickly introduce myself so you can understand like who am I, because anyways we'll have to stay together for next couple of weeks. So let me introduce myself. My name is Amit Kulkarni. I'm having more than 18 years of experience in developing, So it's like crafting technology solutions, means I am working here in Sunbeam as associate technical director. At the same time, I'm a passionate freelance developer as well. So I live two lives. Earlier in the morning 8 o'clock to 1 o'clock, I deliver the sessions here in Sunbeam. And after 2 o'clock, I change my hat and I become a freelance developer. I have my own clients where I develop the real world applications, deploy them, maintain them for my clients. So most often, I mean, actually, to be honest, I started my career way back in 2007 as an iOS developer. Then I started with Android by using the native development. Like in iOS, I use Swift. In Android, today we are using Kotlin, but I mean, I was using Java also once upon a time. So iOS and Android native applications. Then we started developing the PHP applications. Then Mean, where Mean stands for Mongo, Express, Angular, and Node. And then I added Mongo, Express, React, and Node also. So I today I'm developing many different type of applications like Angular applications, React applications, backend applications, and so on and so forth. One of the four famous languages that I use here is like C and C++. Whenever there is requirement of performance, so there I have to use C and C++. There's no option. Python I use a lot for ML because I develop the applications for ML as well for my clients, automating their applications or automating their database connectivity or automating their different situations or getting the data and creating the AI applications for them. So that's what I generally do. And that's where I use Python a lot, a lot. I use the JavaScript a lot when I go for developing the React application and use a TypeScript for developing something like an Angular applications. Mostly I use Go for developing backend applications today because Go is a very performance oriented language. If you are looking for best performance, you should focus on Go. It's a simple as well as give you good performance compared to C and C++. So generally I use Go for backend development as well. I use backend development using JavaScript and Express as well. Again, it depends on the budget of the client and then time requires to develop that application. So there are multiple factors available out there. So the other languages I generally use for specific reasons. I use Swift for iOS as I mentioned. Kotlin I use for Android development, Android native development. And PHP, I stopped using it because nowadays there is no requirement for PHP. Earlier, I used to develop that applications a lot because people were looking for PHP developments. Right now, there are no requirements of PHP, so I stopped using PHP. I think last couple of years, I now developed a single application with PHP. That's why because clients are not looking for one. Anyways, other than that, I love the administration. I love the DevOps part as well. I hope you might have heard about DevOps. DevOps stands for Dev, that's like developers, and Ops stands for operations team. This is again very popular term in today's world, and if you know this stuff, you can complete the end-to-end development for your client. In a sense, I can develop the applications, I can deploy the applications, I can maintain the applications. That's how I do that in the today's environment, or you can say in real world environment. So under DevOps, I use Jenkins for CI/CD pipeline. Again, GitHub Actions for CI/CD pipeline. Argo CD for continuous deployment. Generally, I use for Docker, which is one of my strength, or you can say this is one of my favorite applications because this is kind of the one which has changed my life a lot. Docker. I use a Kubernetes and Docker Swarm for orchestration purpose, Terraform and Ansible for automation purpose. So there are multiple different things I do in DevOps, and I provide DevOps support to my clients also. So actually, when I say I'm working as a freelance developer, I develop the applications for my client, real world applications, real world clients. I have many clients from US and UK and some other countries available throughout the Asia. But most often, I develop the applications in Angular, React, iOS, and Android. These are my, you can say, core areas. And of course, all of them using the machine learning as well. And of course, I provide DevOps services to them. I've got certain certifications under my belt. For Kubernetes, I have both application developer and administration, which is called as an administrator, Kubernetes certified administrator, Jenkins certification, then the Docker certification, and the Linux certification, and the security certification as well. So a couple of certifications I have got under my belt. There are a couple of more I stopped showcasing them because they already got expired. It's way back, like RHC, Oracle's DB, and so on and so forth. Anyways, a quick introduction about myself so you can understand like who we are or who you are talking to, so you can ask any type of questions out there from different industries as well, so there is no problem at all. Yes, good question, Shubham. Are we going to consider real world applications? There are four capstone projects we are going to develop in Python, Shubham. For your understanding, there are four capstone projects. Capstone project means real world applications. One of them is developing the entire GUI applications using something like simple, I didn't mention that here, simple Streamlit application. This is not default one. I can put it here. For developing a simple website like applications, we'll be using a Streamlit, and we'll consider this as our GUI application. Very simple. Streamlit is a very simple, at the same time, probably a very important one in ML and AI as well, because this is something which is used a lot. So you can showcase what kind of model that you are developed. So Shubham, we're developing 4 capstone projects. 2 of them will be using Streamlit, and 2 of them are console applications, but they are end-to-end applications and real-world applications. Tomorrow, I'll show the demo of them as well. So today we'll start with the actual contents, and tomorrow I'll show you how these contents are used to develop the real-world application. So stay tuned for tomorrow's session, Shubham, and you will understand what kind of 4 capstone projects we'll be developing. Out of them, 2 are Streamlit and 2 are console applications, but they are end-to-end applications. Okay. So I hope that answers the questions. Wonderful. Okay, so these are the contents that we'll be developing, or sorry, we'll be learning in this particular Python module or Python course. This is something about myself. Now I think we are kind of through with what the contents are. We'll start with the actual contents of the course. As I mentioned last time, I know most of you are just passed out and most of you are starting Python as your first language. So I will not consider anything as a prerequisite for this. We'll start with very, very, very fundamental part. We'll start with the language fundamentals first. I mean, I don't want to start with the Python unless you understand what exactly the language here is. As I mentioned, Python is a general purpose programming language, but you should understand what is a language in the first place. So let's understand what is a language, what different types of languages are available, and how the languages will help you to convey your thoughts, convey your, maybe you can say, operations towards your computer. So simple and very fundamental question: what do you mean by computer language? Forget about computer language for a second. Just say language. What is a language in general? Like, I'm using English as a language. What's my intention here? My intention here is to give my understanding to you, or to provide a communication with you. So this way, I can interact with you by giving my thoughts or by sharing my thoughts by using language as a medium. So in general, English, Hindi, Marathi, and so on and so forth, all of these are the languages we use to communicate with the people. Similarly, a computer language is a medium to interact with the computer. Now, this is a simple goal. I want to communicate with my computer. I want to interact with my computer. How do I do that? I convey my thoughts, I convey my logic to the computer by writing some code by using a computer language. So computer language is just a medium. That's it. A language is used to solve the problems by giving some kind of solutions which are implemented or which are written in terms of something called as a programs. So in short, my intention here is to solve some problems by writing code by using one of the languages and creating a program so that computer can understand what I want that computer to execute the code. So this is what we generally go for. Now, in general, there are many languages out there, but these are 2 fundamental ones. One of them is called as something called a machine language. Another one is called an assembly language. Now, what do you mean by this? To understand this, first you need to understand what exactly the use case here is. Now, try to understand this. This is a very important for you to also give you an understanding of what do you mean by low-level languages, high-level languages, what do you mean by compiled languages or interpreted languages. All of these topics, I'll cover them in this particular diagram. So pay attention here now. I just mentioned a language is a medium to interact with the computer. Now, when I say computer, what in the computer I want to interact with? I mean, if I consider computer has got many different components inside it. So consider this as my computer. Inside it, I can say this is my hardware. This is my computer. This is my computer's hardware. So if I look at my computer's hardware, I've got many different components out there. Something like a CPU or something like a memory. We call it as a RAM, for example. So there are multiple different things. Or maybe I can say there is a disk, or maybe I can say there is a GPU, or I can say there is a network interface card, and there are many other stuff out there. Now, when I say I want to interact with my computer, whom should I interact with from my hardware components? So the most important component in my hardware, in my machine, is the CPU. We understand, I hope you know that. A CPU is considered to be the brain of your computer. When I say brain, all your instructions or all your computer works just because of this CPU. So CPU is the one which is going to help you to execute the code or to perform some operations by using your own logic. This is the CPU. Now, CPU is a mechanical device. Now, when I say mechanical device, it understands the current. Precisely, and when I say it's a mechanical device, it understands only the current. And this is how earlier people were interacting with CPU by sending some electrical signals. Like, I don't know whether have you heard about this, something as an altair. Just a second, I'll give you a small example so you can understand what exactly this one here is. This is called an altair. Altair is very important, or very this is the one I'm talking about. It's a very important fundamental shift in case of computers, and this is what I'm talking about here. See this. This is called an Altair. This is one of the first computers. This is one of the first computers I'm talking about. 1950s I'm talking about here. So you can see that there are switches here which were passing the actual currents to those systems so that they can perform some operations. Like there are the switches here, and the instructions were getting passed by using the binary systems. So ultimately computers, CPU understands the current, but it becomes very difficult for you to pass the currents, and that's why the scientists have developed a simple language called as binary on top of it. I bet you all know what exactly the binary means. Binary means it is a language which is made up of only two things. One is the zero and another one is the one. So there are only two things inside the binary. So actually CPU understand the current, but it becomes very difficult. People were doing that earlier, but it was very difficult for them to send the current in the form of plus 3 or minus plus 5 says plus 5 volt. It was very difficult for them to program it. That's why they come up with an idea that instead of passing the raw current, they provided a system to write some logic by using the binary system. So binary, there are two options. Either you can go for 0 or you can go for 1. So now, instead of passing the currents directly, people or the scientists or the programmer started sending the binary signals like 0 1 0 1 0 1, so on and so forth, like 0 1 0 1 0 1 0 1 1, so on and so forth. So when I pass this instruction, when I pass something like this, for example, what is to happen is like the binary system was getting kind of converting your instruction into the currents. So when I pass 0, certain currents was getting passed to the CPU and CPU is to perform that operation. Again, when I pass 1, that 1 will force the disassembler, you can say assembler, to pass a particular current to the CPU. So the CPU was ultimately getting the current by passing something like a binary instructions like this. So people started developing the applications using the binary code at that time. But developing applications using binary was also started becoming difficult, and that time they used something called as the assembly language. This is what I'm talking about here. So the binary language is generally considered as the machine language. Machine language means what machine can understand. When I say machine, don't get a wrong understanding here. I never want to communicate with my keyboard or my mouse directly. I want to communicate with the CPU because that's a brain. If I communicate with the CPU, CPU will communicate with all of them internally. I don't have to worry about that. So my intention here is to communicate with the CPU. And to do this, I'll be using this machine language. So this is the code I'm talking about, which is written by using zeros and ones. That's it. And they can be directly executed by CPU. So if you are here in terms of binary, you are kind of giving the instructions by using 010101, which was getting converted into required current that CPU can understand, and CPU is to perform the operations for you. But as I said, it was very difficult for the developers to pass the instructions using the binary codes like zeros and ones. That's why the CPU manufacturers came with the idea of something called as assembly language. What is it? It's a language which is closely related to one or the other family of machine languages which use the mnemonics to ease the working. This is called as a mnemonic. Mnemonic means it consists of two things. Like for example, if I want to pass a particular instructions, I don't have to worry about the binary code here. I can say something like add. This is what I can do in binary. In assembly, something like an add. Maybe I can say A0 to B0. For example, I'm saying where the A0 and B0 are the registers inside the CPU and add is an instruction. So think about this. There are two parts of your system. One of them is nothing but the instruction, which will help to understand like what exactly the operation user wants to perform. And another one, these are the operands, which will help understanding like where the data is coming from or where the data needs to be stored. So there are two aspects of it. One is the mnemonic. Mnemonic means it is the instruction that you are passing. This is the mnemonic, and these are the operators. So operands rather, which means I don't have to bother about something like the binary code here. I can pass add A0 B0. The assembler here converts it into the proper binary. So it will convert the add instruction to the binary. The binary will give the proper current to the CPU, and then CPU will perform the operation as I mentioned here. So A0 B0. So it will get the value from A0, it will read the value from B0, add them together and store the value in terms of A0 register. So that's what it does. This is called a mnemonic. Mnemonic means it's an opcode, or it's called an operation code, which is the instruction to the CPU to perform an operation. This is also known as an opcode. Opcode means operational code. So you are asking CPU to perform a particular operation by giving this instruction called as an add. Okay, now see this, see the evolution of this. It was started earlier to directly pass the current to the CPU to perform an operation. It was difficult for them, it was difficult for programmers to pass the current directly. So they came up with an idea of binary. So binary is where you can pass zeros and ones instruction, which was getting converted into required current, and then CPUs to perform the operation. It was very difficult for developers to pass the binaries, and that's why they came up with an assembly language. So binary means machine language, and assembly language is something which is developed by the CPU manufacturers, and this one will kind of convert itself into the binary, which will get converted into current, and the CPUs to get the current. This was kind of a story way back earlier. I'm talking about 1950s or 70s, you can 60s to 70s, you know. Then people started finding assembly also difficult. I mean, say it's not difficult, I would say, but lengthy. Even if they want to perform a small operation, they used to write hundreds of lines of code. And that's why they thought of doing something better. There were two scientists. One of them is known as the Dennis Ritchie. I hope you might have heard about this. The Dennis Ritchie, the person who has changed the computers industry, you know, by developing a language called as C. And of course, he was the main contributor in the Unix operating system as well. Ken Thompson and Dennis Ritchie developed the Unix operating system, and Brian Cunningham and Dennis Ritchie have developed the language called the C. So the problem here, Dennis Ritchie observed, the assembly is a CPU specific. Now I'll put some important points here because I want to remember them, because this is something we will be discussing in the Python also, like why Python is famous. I'll answer that question end of the day today. But understand this: when I say assembly language, it's good that I don't have to worry about passing the ones and zeros right now. But the problem with the assembly language, it is the platform specific. Platform specific. What do you mean by platform? Platform means it is, instead of saying platform, I will use a better word here. It's called the CPU family specific. So this is a CPU family specific. CPU family, there are many different CPU families out there which will be used in different contexts. Like the one that we are using in our machines, it is called the CISC family. CISC stands for complex instruction set computing. Where Intel processors come in or AMD processors come in. These are very famous processors which we are using in our day-to-day environment or in our machines as well. Then comes the RISC. RISC stands for reduced instruction set computing, complex instruction set computing and reduced instruction set computing. So these are the processors you can find inside mobiles a lot, you know. So if you are using Android, if you are using iPhone, all of those machines or all of those, you know, the phones or mobiles are using the RISC processors inside them, which are developed by many different companies out there. Sony's one is called the Ericsson, or maybe you can say Samsung has got Exynos, you know, Samsung, or Apple has got the A series and M series also. So there are many different manufacturers out there. Apple, or one of the famous is called as a Qualcomm Snapdragon, it is called as. So there are many different providers of the RISC processor. Other than that, there is something called the Spark, which is like Sun processor architecture. It is known as S for Sun, P for processor, ARC for architecture, Sun processor architecture, and there are many others, MIPS and so on and so forth. You know, so there are many different options available out there. MIPS it is known as, and there are many different options available out there. So these are the CPU families. Unfortunately, every CPU family has got its own assembly language. What it means here is, let us say this is x86, which is nothing but something like the CISC. So let us understand, like I have written a program here. This is like using x86 assembly language. Now, if I write the code in x86 assembly language, I could pass this code directly to the a CISC processor and it would execute without having any problem because the processor understands assembly language. If I pass it to the mobile, mobile would not work on this, or mobile would not understand that because this one is specifically designed to designed to the CISC. So what happened while developing the Unix operating system? This is what Dennis Ritchie's main problem was. He developed the Unix for the first time using assembly language for a computer called as PDP DEC 11. So the problem here is when he developed that using one assembly language, he wanted to write or he wanted to run that Unix on another machine at that time, Honeywell architecture. But unfortunately, the assembly for one machine was completely different than another machine, so he could not run the same program on two different processors because every processor has got its own specific assembly language. That's where the problem started. So Dennis Ritchie has rewritten the entire Unix for another computer, but he thought of it like, why am I doing it all the time? Because if the processor changes tomorrow, I have to rewrite the entire application using the assembly language supported by that processor. So he came up with an idea saying, instead of rewriting the code every single time in assembly, why can't I do something here? Check this. Why can't I do something here that will solve my problem once and for all? And this problem can be solved by using one of the two options available here. This is what I want you to understand today. One of them is called as compiled languages, which is what Dennis Ritchie has given, compiled language or compiled languages. And later on, to solve many of the problems of compiled languages, they created something called as interpreted languages. So understand the basic fundamental stuff here. This is a category called as a compiled language, which is going to give you an understanding of writing a code and converting it into assembly instruction. And interpreted language also does the same job, but it does in a little bit different fashion. Check this out. So Dennis Ritchie came up with an idea of compiled languages at that time by writing a program, by writing a language called as C. So this is what generally you can see here. Let's say I've written a code in hello.c. So this is my code. I've written my code using C language by creating a file called as hello.c. Now C language has got a code written in C format. If I pass this code directly to the CPU, CPU cannot understand that. And that is the reason this hello.c will be passed to a program called as a compiler. What is a compiler? A compiler is a program which understands the language for which it is developed. Like it can understand the code written in C. And this is the code, or this is the program which will create something called as the binary code or assembly code, I can say. It will generate the assembly code for that particular processor. This is the assembly code. Again, this is the compiler's job to create an assembly code for a particular CPU. This is the assembly code. Who does it or who converts it? It is the compiler's job. So you pass the C code to the compiler and compiler creates an assembly code. Now hold on for a second. I hope all of us are not directly using our machines, but we are using the machines by installing one system software on top of it. I'm referring to something called as an operating system. See the problem? This is an operating system. Say for example, there are three operating systems which are very famous. This is called as an operating system. This is the layer which is on top of your hardware that we are directly interacting with, right? So as I was saying, there are three operating systems which are very famous, starting with Linux, then there is a Mac, and there is a Windows. So there are three operating systems which are very famous, and probably you are using one of them on your machine at the moment. Most of you are using Windows, I believe. So this is what you are running on your machine. Now see the problem. The problem here is I cannot directly communicate with the CPU. Even if I want to, I cannot directly communicate with the CPU. I'm communicating with an operating system. An operating system internally communicates with the CPU. If I pass this assembly program to the operating system does not understand any damn thing out there. And that's the reason why we are going to bring one more program in between called as a linker. See the problem and see the solution, how Python solves this problem. So this is the linker. Now what linker does? Linker creates a operating system specific executable code for you. So this creates an executable. So this creates an executable which an operating system can understand. So we can pass it to the operating system and get our job done. See how this compile language and interpret language are solving two different types of problems. I have written a program here in C. I cannot directly pass it to the CPU, so I've used a compiler, compiled it to get the assembly code. Then I used the linker to create an executable, and then I double clicked on that executable and I passed that to the operating system. And operating system internally has passed that to the CPU and got it executed from the CPU. Because CPU can understand assembly code, the operating system took this assembly code from the code and passed that to the CPU, and CPU happily executed that code and giving me an output. So this is what the compile languages are. See the point here. When I say a compiler here, please pay attention to the word that I'm using right now. The compiler here is a CPU family specific. Means if you are using a x86 processor, as I mentioned here, x86 means sys processor. If you are doing it for your desktop, then this compiler will generally this compiler will create assembly code only for that particular CPU family. If you are using it for a RISC, the code which will be compiled by the compiler will be compatible with only the RISC processor. So this is a CPU family specific. Remember this point, compilers are always CPU family specific. While the linker which is used for creating an executable, this one here is the operating system, or we call it as a platform here. So platform means operating system. So this is platform or operating system specific. Understand the basics of languages, So when you are going for a linker here, this is always operating system or platform specific. And when you are going for a compiler, this is always a CPU family specific. Which means if I've written a code, let's say a simple application, and I want to make it available for Linux, Mac, and Windows, like for example, Office. Office is available on all the operating systems, right? So I want to develop an application which I want to run on all the operating system. If I'm writing this code in C, I have to compile it and link it 3 times. First time for linker on Linux, or you can say creating an executable for Linux. Then I go for macOS, and then I can go for Windows as well. The best example of it, maybe I can just go back here and say, if I want to say download Chrome. So if I say I want to download the Chrome, I don't want to download it right now, but if you look at this, it is telling me you can download it only for macOS. In a sense, if I download it on macOS, when download it for macOS, and if I go for copying it on Windows, it is not going to work, because I think if I look at these guys have changed the layout, I believe. Maybe I can just say different operating system. Is there an option available? OS, compatible additional tabs. No, not that. I'm looking for the other operating systems available here. Let's search for others. Is there any way I can find it out? Other platforms, here it is. They have changed the link now. So if you look at this, they are giving you options, different operating system, the different package for different operating systems. So if I select Mac, you will download it for Mac. If I select Windows, it's going to download it only for Windows. That will not available on Mac. I mean, that will not be able to, you will not be able to install it on Mac, not able to install it on Linux, which means when you are going through this path, the executable that you're going to create is always going to be operating system specific. This is the major problem of compile languages. See this. When you are going for a compile language, this is very good performance, or this will give the very good performance, but the main problem here is this is a platform specific. This is what I'm talking about, compile language. Compile languages are the category of programming languages where the source code is translated into machine language or another intermediate language before it can execute it by a computer. So if you look at this is the compile language. It is going to be passed to the compiler. Compiler is going to create the assembly code, which is going to get converted into machine code later. Again, it's going through the linker and create an executable for a specific operating system. This is a compile language we are talking about. This translation process is typically handled by a compiler, which converts a high-level code into executable instructions that can run on a specific hardware format. This is a very important point, CPU specific, as I mentioned, or CPU family specific. This is the compile language we are talking about. Okay, so compile languages generally offer a better performance than interpreted languages, but they are less portable because the compile code is specific to the particular architecture. So you see there are two things here. One, It'll give you the better performance. Means if you're looking for the best performance, you should go for C or C++ because both of them are compiled languages. But what's a disadvantage? What's a downside of it? They are specific to the particular architecture. So if you want a same application to be available on 3 operating systems, you have to compile it and link it thrice. As you see here, in terms of Chrome is available on all operating systems, So you see that these guys have developed this application once, but kind of made it available for 5 different operating systems. And if you're doing it, you have to compile and link the program 5 times. This is the disadvantage of it. So you have to select the Mac and download it for Mac. You will select the Windows and download it for Windows, so on and so forth. I hope you understand what am I saying here. So there are two things here. It will give you the best performance, but it is specific to operating system. So it becomes a nightmare for you if you are going to support multiple operating systems there. For example, C, C++, Go, C Sharp, and there are many different options available out there. So these are all compiled languages. They are faster execution speed. They are the key characteristics we are talking about. They are very memory efficient and they will go for static typing. Static typing, I'll explain this day after tomorrow, or maybe tomorrow, we'll see when we go for data types. So there are two types of systems, statically typed language and dynamically typed languages. We'll talk about that a little bit later. But right now, I think you understand the compiled languages will give you a compiled code and then you convert it into executable that operating system can understand. So that is an operating system specific executable that you have created. Wonderful. But what if, let's say, I want to develop an application which will be compatible with all operating systems there without me compiling it multiple times? How do I solve this problem? This problem will be solved by using something called as an interpreted languages. There are many interpreted languages out there. One of the simplest language, which all of you must have heard about it, something called as an HTML. HTML is one of the simplest and one of the famous interpreted languages out there. It uses a program called as an interpreter. So this is something called as an interpreter. Now what interpreter does? Interpreter does exactly what the compiler does, but in a different manner. I mean, if you remember what I said in the compiler's case, compiler converts it into assembly code, then it passes to the linker and it creates an executable. So there is no need of creating an executable here because in terms of interpreted languages, the interpreter directly will convert this code and passes this to the operating system and get it executed from the CPU out there. So precisely when you are going for interpreter does not require any linker because it does the interpretation of your code line by line. It's called as a line by line execution. Line by line execution. So it converts your line, it executes your line, then it goes for the next line, then it goes for next line, so on and so forth. In case of compilation, it compiles all lines to the assembly code first, and then by using linker, it creates it into executable, and then you pass it to operating system and get the job done. Here it does not happen like it. The interpreter will execute your code line by line, precisely dynamically. This is what we are kind of looking at right now. Okay. So, okay, Sandeep. So when you are talking about the compiled languages, we are going to convert our C code or compiled language code into assembly code first. Then we convert it into executable, and then we generally go for passing it to the operating system so that operating system can pass it to the CPU and execute your code. When you are going for interpreted language like HTML, for example, JavaScript, for example, all of them will have their own interpreters. Best example for HTML, the interpreter is browser. I guess you already are using browsers a lot. So browser is one of the default interpreters for HTML code. So if you are using HTML, you have to open it into the browser. So the browser is acting as an interpreter which understands what you have written in HTML and directly executing it with the help of CPU out there, with the help of operating system and with the help of CPU out there. This is the major difference between compiled languages and interpreted languages. In compiled languages, you are going to get an executable. In interpreted languages, your program itself will get executed line by line. This is the major difference between them. See, my program does not execute. My program's executable gets executed, and here my original code gets executed. That's why it is interpreted language. It's line by line execution. This is all the lines will get converted into the assembly code, and then you are going to get executed here. Here, all lines will get executed one by one. This is the major difference between interpreted and compiled languages. This is called as a static compilation. This is called as a dynamic execution of your code. So this is what we are talking about. In compiled languages, C, C++, Go, C Sharp, best examples. While in interpreted languages, understand this now, in our case, the interpreted languages is a category of a programming language which are used for which most of them or most of their implementations execute the instructions directly and freely. Directly means you don't have to worry about converting into executable. Your code will run line by line directly and freely without previously compiling a program into a machine language instructions. Have you noticed a difference? Here I was getting an executable. Here my interpreter is executing the code directly. There is no need of converting your code into executable. So this is the advantage of using interpreted languages. The interpreter executes a program directly, translating each statement into sequence of one or more subroutines and intermediately carrying out the actions. So here you are not going to create an executable. All instructions will get executed. All code lines, all the code statements will get executed one by one, line by line. Okay, that's the advantage of using interpreted languages out there. This is in contrast to compiled languages where the code translated to the machine language before the execution. Here, your code got converted into executable. Here, your code directly got executed line by line. That's an advantage of using interpreted languages. I think you understood the advantage here, right? And advantage of it here is you don't have to be worried about which operating system am I using right now. Think about this. If I want to browse Amazon.com or Google.com for that case, I don't care whether am I using Mac, Linux, Windows, iOS, or even Android, because the same website will open or will give the same output in any of the browsers out there, because all browsers are nothing but my interpreters. So I'm not getting any executable of it. I directly will open the URL in my browser and get the job done. Very simple and very straightforward. This is known as an interpreted languages. The language that we are going to learn right now, this is called the Python, JavaScript, Perl, Ruby. All of them are interpreted languages. I'm going to put a star mark right now on top of a Python because Python is not truly interpreted. Python is having both interpretation as well as compilation. What's the meaning of it? I'll explain that a little bit later today itself. But I'm going to put a star mark here on Python. Consider it to be interpreted, but it's both interpreted as well as compiled language. Now, what are the key characteristics of it? Number one, it is a slower execution speed compared to the compiled languages. I hope you understand that here. Every single code will get converted into assembly code line by line, and then you are going to execute it. So line by line execution means line by line translation to the assembly code. So let me write it here. This is line by line or statement by statement, the assembly code conversion, ASM conversion. So if you understand what am I saying here, every single line first gets converted to assembly and then will get executed. Again, second line, first assembly code and then execution. Third line, first assembly code and then execution. You see how much time it's going to take? Here, all lines already got converted into assembly code and you just are going to execute it by using an executable. There is no executable. Every line will get converted into assembly first and then it will get executed again, again and again, again and again. And that's why the interpreted languages are much slower compared to the compiled languages. So this is the disadvantage of it. But the advantage of it is like more portable than compiled languages. Portable means if I write code once, I can execute it on Linux, Mac, Windows, iOS, and Android as well. For example, HTML code. Here, on the other hand, we have to compile this code for different operating systems differently. You saw that in example of a Chrome. So the browser itself is a compiled languages output. All browsers are developed in C and C++ precisely. That's why all browsers are giving you the executable that you have to install it on your machine. And those executables are available on different platforms differently. You cannot download it for Windows and install it on macOS. It's not possible because it's an executable which is platform specific, operating system specific. And that is the difference between the compiled languages and interpreted languages. I hope you are getting it. Another advantage of it, it's very easy to learn. It provides a dynamic typing. Tomorrow I'll mention it. Dynamic typing. And memory management is very simple compared to the compiled languages. I bet you all have heard about a language called the C. And one of the reasons why people hate C is its pointer, which is nothing but a memory management. I bet you already have heard about the pointers also. Many people generally hate it. Many people are kind of scared of it, I believe, right? Why are they scared of pointers? Because pointers will give you the option to manage the memory. And if you do not manage your memory well, your application either will crash or will leak the memory. So it's like if you do not manage the memory well, your application will crash if you are kind of maybe releasing it or removing that memory twice accidentally, or if you do not release the memory, if you do not release the allocated memory, then it will leak the memory, and that's another problem that you have to solve. So it's very difficult to manage the memory here. Whereas in interpreted languages, the memory management happens automatically. This is generally called as automatic memory management. And that's why we are saying this is very simple to manage the memory in terms of interpreted languages. I hope you are able to understand what is compiled languages and what do you mean by interpreted languages. And you have understood that languages like C, C++, Go, C Sharp, all of them are compiled languages like Python, JavaScript. There are many other languages which are, maybe you can say Ruby, for example, Perl, for example, PHP, for example. They all are interpreted languages. Guys, may I know if you have understood this? If you still have got any question, please go ahead and ask. This is an important point that we are discussing today. So Python understanding depends upon whether you have understood, compiled or interpreted, because later today when we start our first Hello World Python application, I'm going to say Python is both compiled as well as interpreted. You should not get confused at that time. Any questions so far? Aditya, since you are introducing some programming language specific to the CISC or RISC, by the way, the spelling is different, CISC and RISC. It's not RISC. It's not Ram Gopal Verma's RISC. I'm talking about RISC. Reduce Instruction Set Computing, it is known as. It is recommended for us to take the notes manually or outside, or do you suggest a better way to increase our productivity? Good. Whatever I'm writing here, whatever I'm showing here, and whatever I'm going to draw here, I'll be sharing every damn thing with you. Aditya, and not only for Aditya, for all of you, I'll be providing all the notes in your Git repositories. Every single day, once we are done with the session, I'm going to commit my code so you can pull that code on your side and start reading it whenever you want to. I'll also provide the notes to you, not today, maybe a couple of days after when we start doing some major stuff. I'll provide the notes also, not only this. Other than that, I'll be providing notes also and interview questions as well whenever we go for that topic. So do not worry about that. Aditya, I think that answers the question. That answers your concern as well. Okay. Any other questions specifically on compiled and interpreted languages, guys? If you still have got any question, please unmute and ask the question. Yes, Shashi, go ahead.
Yeah, I have a question. Thank you. So when you are saying it can be compiled as well as interpreted, so how? I mean, both are two different things, right? So how? I mean, is there something as an end user we need to do or some setting? I mean, I
No.
didn't get that. Yeah.
Exactly. And that's why I want you to understand right now what is a compile and what is interpreted. Because later on, once we are done with this, once we start with the Python as a language, I'll mention it. There is something of the C Python, which will go for 4 different stages of it, like the parser, like the compiler, like the interpreter, and like the runtime. So hold on for your question. You will get an answer when we go for this topic, okay? Because that is something will kind of give you an understanding of how the compiled and interpreted languages features are mixed in the Python. So Python is little bit slower, but it also will give you an understanding of write once and execute it anywhere. Like if you see here, you are writing HTML only once and it is available for all of the operating systems there at once. You don't have to worry about rewriting it for different operating systems. The same philosophy is carried forward in Python as well. Okay, I'll mention that in a minute. Just hold on your question and you will get the answer. Other than this, anyone having any question, guys? Yes, anyone having any question other than that? No? Wonderful. Okay, let's continue further in that case. Okay, so I already have provided the comparison between high-level languages and low-level languages. It's for you. You can read it later. I don't want to read all the lines one by one. I also have compared compiler and interpreter again line by line. You read that later. I already have given you the entire context of it. I think you can easily read that code later. It is exactly what I mentioned earlier. Now that you have understood what exactly what exactly do you mean by the interpreted and compiled languages, I think we should start talking about our main subject, what is Python. So let's understand what do you mean by Python. Okay. I'm sorry, before we go for that, very quickly, because something that I want you to, I don't want you to miss it. Other than this, machine language and assembly language, there are different type of programming language categories out there. For example, there are general purpose languages, those programming languages which are broadly applicable across different application domains and lack specific features of a particular domain, which means these kind of languages are used for developing different type of programs. Like for example, Python is a general purpose programming language, or C is a general purpose programming language, even C++, or even there are many others. All of them are general purpose, means you can use that language to develop any general purpose application. They are not tightly or they are not specifically bound to the specific domain. What's the meaning of tightly bound to specific domain? See this example here. There is a category called as a markup languages. Markup languages means it is a grammar for annotating document in a way that can syntactically or maybe you can semantically distinguishable from the text. What's the meaning of this? I hope you might have heard about a language called as a HTML. Now what is HTML? Probably HTML stands for Hypertext Markup Language. This is the language which is mainly used for designing the websites. So HTML is a tightly integrated or tightly bound with the web programming itself. I mean, you cannot use HTML to develop a console application. You cannot use HTML for compiling your application. It's not possible because it is a markup language, and markup language has got a specific requirement. Another markup language which is very famous is called an XML, extensible markup language it is known as. Both of them are having their own domains. You cannot use this for any other purpose. I mean, using HTML you cannot write a console application because it is tightly bound with designing a GUI. This is what I said. These languages are tightly bound with a specific domain. These languages which will not kind of bound with any kind of specific domain known as general purpose programming languages. There's another one, something called as a style sheet programming language, or style sheet languages they are known as. What do you mean by style sheet languages? Those are the computer languages which express the presentation of a structured document. The best example, again, in terms of website is called the CSS, cascading style sheet it is known as. This is used only for designing the web pages. HTML is used for something like designing the web pages. CSS is mainly used for decorating them, not designing, decorating them. Like using HTML, I can create a design and then I can fill the colors, I can change the positions, I can add some different fonts and so on and so forth. Decoration will be done by style sheet languages like CSS. Then there is something called as a category known as a configuration languages. What do you mean by that? The language or the languages category used to write some configuration files. When you are developing a big applications, you do not want to hard code the settings of your applications inside the code itself. It becomes very difficult for you to manage it. And that's where the configuration languages come into picture. For example, JSON, one of the best examples to create a configuration, JSON. Or we can go for .config. Config is also a configuration that you can go for. XML can also be used here. YAML can also be used here. So there are many different configuration languages. Very famous query languages. They are mainly used for communicating with the databases. A language used to make the queries in a database and information systems. The best example you might have heard about it is called as an SQL, standard query language it is known as, So SQL, we generally call it as. So this is the query language, which is tightly bound with communicating with the database, nothing more than that. Only database. Other than that, you can't use it for writing a console application. You cannot use a GUI application. You cannot use it for machine learning. No, it just used for communicating with the databases, SQL, tightly bound with the domain. Another one, a scripting language, a language which is used to write the simple to complex scripts. And there are many categories also. There are many examples, so there are many languages in this category. One of the famous scripting languages is something like Python. Yes, Python is also a scripting language. Scripting language is the one which does not create any executable. Most of the scripting languages are by default interpreted languages. They do not have any kind of entry point functions. They do not create any executable. Again, Python is one of the best. Another one is something like a JavaScript. Another one is something like a Perl. There are many others. I don't want to mention all of them, but you can understand there are many others. So all of them are called as the scripting languages. So all of these will kind of used for developing simple scripts. These are called scripting languages. So when you are going for something like the programming languages, there are many categories out there. The language which is used for performing different tasks is known as a general purpose programming language, and Python is one of the best general purpose programming language out there. So remember this point, because I'm going to mention that. What is a Python? A Python is a general purpose programming language, which means it can be used for developing console applications, it can be used for developing GUI applications, it can be used for developing AI ML applications, it can be used for developing different type of applications out there. That's why it is known as a general purpose programming language. Let's understand this. So what is a Python? When you're talking about the Python, Python is a programming language which is high level general purpose programming language. As I mentioned, it is high level because it's not an assembly or it's not a machine level language. It's called a high level language, and this is a general purpose. As I mentioned, it can be used for developing different type of applications out there. Who has created it? It is developed by Guido van Rossum in 1991. Remember this. This is a pretty old language. It's not new. It's pretty old. But today's industry is kind of dependent on Python for writing the AI/ML applications because it's very simple to learn for the developers and is sufficiently giving you the performance compared to the other languages. That's why people use that language for machine learning today. It's developed in 1991. That old language we are learning today. Readability perspective, it's known for its very simple and clean syntax, emphasizing the code readability. Guido van Rossum once said that he was working with many developers who were developing the C and C++ language, C++ coding. He said, I've seen many people not following any kind of standards or any kind of the coding. Maybe you can call them as the coding best practices. And that's why he said, I wanted to develop an application which will give me the power of C and C++, but at the same time, I don't want to write I don't want people to write the code in ugliest fashion, not following the best practices. So he developed he developed an application called as, or language called as, a Python, which is a combination of giving the great power of C and C++, at the same time the simplicity of scripting languages. That's why it has got a very simple and a clean syntax. At the same time, it makes your code very much readable because there are no curly brackets here, rather indentation. Yes, indentation is used for the code readability. I think I'll just mention it here, indentation. So tomorrow, if you want to write a function, tomorrow if you want to create a block, tomorrow if you want to write, let's say, for loop or if loop or if condition, you can't use a curly bracket here. Indentation is used for the same. Tomorrow I'll talk more about this, but today I'm just mentioning that to make the code more readable or to enhance the code readability, Van Guido Rossum forced the developer to follow the indentation. He has said that I've seen people writing a very ugly code in C, C++, and he said, my language, if you're using it, you have to follow indentation. If you do not follow indentation, your code will not even compile. So that's why Python code, even if you write it in any way, it will be by default readable because you have to make that code more indentable. If you don't, your code will not even work. This is the reason why people love Python. It's very simple to read the code and very simple to write the code as well. It's an interpreted. As I mentioned last time, it's not only interpreted, it's interpreted plus compile, but right now I'll say interpreted. Python is an interpreted language, meaning the code executes line by line. This is very true. The code will get executed line by line. It will not get converted into any executable. I'll explain what happens in a minute, but understand this. Python code is interpreted. It is compiled plus interpreted, but more or less from the end user's perspective, it is going to get interpreted first. It is having a multiple paradigms. It supports multiple programming styles like procedural. You don't have to write classes for that. You can directly start with a simple code. It can also support object-oriented programming. We are going to learn that later. Functional programming, aspect-oriented programming, and there are many different things you can learn here. It has multi-paradigms inside this language. It supports cross-platform. Because it is interpreted, you don't have to worry about which operating system that you are using below your code. In a sense, it runs directly on various different operating systems like Windows, Mac, and Linux. Abhishek, you have any question? Okay, I think you must have got unmuted accidentally. No worries. Oh wow, I can't unmute you. Fine. Okay, so this is like you can see I don't care about what operating system am I using behind the scene because it is cross-platform. You write once and you can execute it on all the different operating systems. It's open source. You don't have to pay any cost or any license fee to anyone because it's open source. It's freely available and supported by large and active community. You don't have to worry about paying any license fee to anyone. It's a free and it's open source. It has got extensive libraries. As I mentioned, it has got support for more than 300,000 libraries or packages they are known as. And that's the reason it can be used for different type of applications. It comes with rich standard libraries and third-party packages for diverse application. You can use those packages for developing AI applications, or you can use those packages for developing test automations. It can be used for developing the backends and whatnot. There are more than 300,000 packages out there. So you can have n number of different ways you can develop an application using Python. It's versatile, used in web development, data science, machine learning, automation, scientific computing, image processing, and there are many more categories you can develop the application. That's why I said earlier also, Python is one of the most versatile languages out there. And very important, it's dynamically typed. Variables do not require any explicit type declaration, so you don't have to worry about what's the data type of your variable. It will be taken care by Python itself, and we'll talk about this a little bit later tomorrow. What do you mean by dynamic typing? What are the advantages of it? And what do you mean by static typing? And what are the advantages of it as well? Okay. So today I think we are going to see the Hello World applications, and we'll see like what exactly happens behind the scene. Quick history, you can read that later. I'm not worried about it. You can read that later. Now, there are many key features. Easy to learn and use. Yes. It's an interpreted language. Yes. Cross-platform compatibility, as I mentioned. Dynamically typed. We'll see that tomorrow in details. Extensive standard library, as I mentioned. Supports multiple programming paradigms, as I mentioned. So there are multiple different key aspects or key features of it. You can read the C language and Python comparison later. I don't want to waste your time and my time just to read these things, So this is for those who already are coming from C language, so you can understand like what is the C. More important thing or the best thing in C versus Python, its pointer concepts are available in C, and Python does not use pointers. I don't know whether it's a good news or bad news for you, but this is what it is, Python does not support pointers, which is good thing for many of you. This is the important one. So when you are going for Python, there are four major versions of Python. It started with 0.09 way back in 1994. Around 1991, 1994, Van Guderosum, he has released a version 1. In 2000, it's version 2, and in 2008, it's a version 3. Now, why am I saying this here? Is because this is now deprecated. So today, if you are going to install Python on your machine, you have no option but to install version 3. Whichever version that you want to install, doesn't matter. Around 2019, it was 3.7. Today, I'll mention it here. How do we install it on Ubuntu or Windows? On Ubuntu, you can directly go for sudo apt install python 3 and python 3-pip. If you are on Ubuntu, which again, I don't know how many of you are using it, but if you want to do that, this is the code for you, command for you. And if you're on Windows, you can download it from python.org/downloads. So I'll show that here. So if you go back here and say python.org, you can go back here and say the downloads. Under that, you can see the download current version is 3.14. Another important point for you. This is the end of life. You see that it's already been deprecated. 3.9 is also deprecated. You can start with 3.10 onwards. Okay. Now, this is an important point for all of you who want to use Python later for machine learning. And if you want to go for machine learning also, do not go for latest version right now. Do not go for 3.14 or 3.13 or even 3.12 as well. I would recommend to go for 3.11 because it has got very good support for all machine learning packages. So tomorrow, if you want to go for scikit-learn, PyTorch, TensorFlow, XGBoost, and there are many different packages out there which you are going to learn in ML or AI, you can say. So it has got a very good compatibility, and that's why I would recommend to install 3.11. Now, how do you do that? You see that download Python for 3.14. Right now, you can see the latest version of it. But if you select, if you just go down, you can see there are different older versions are also available here. So I would recommend, because if you want to go for AI ML development later, go for 3.11, whatever the latest version available here is. It's like 3.11, 11.15 is the latest version available for Python. Even if you have already got it installed with the latest version, it's all right. There is no problem. But tomorrow, if you want to use that Python for AI or ML, there are there are compatibility issues with the latest version, and that's the reason why I would recommend to go for 3.11. Okay, so I would recommend today you go ahead, click on this and say download for Windows or Linux or Mac, whichever version or whichever operating system that you are using, and get it installed. Just next, 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 and it will install it on your machine. Now, how would I know whether it is installed or not? So you can go on your operating system, sorry, you can go on your command prompt and use a command python minus minus version. So Python minus minus version will tell you which version of Python is installed on your machine. So on my machine, the version is 3.11.12. I don't want to update it to 3.11.15 because I know there are a few packages which I'm using. I don't want to break those packages compatibility. That's the reason. Okay. Later on, when we go for virtual environment, I'll talk about it, like how you can create a virtual environment and use a different version of Python. But today, at least install the 3.11 if you want to pursue this for AI. Even if you install 3.15 or 3.14, it does not matter because the language that we are learning will have the same output in all the different versions of it here. So hopefully you understand, guys. How do I install it? How do I make my environment ready? Very simple. Python is the simplest one you can configure your environment for. Just go for that python.org/downloads. Select your version that you want to install. You can go for the older version. You can see that 3.11.15 is the latest version under that category. You can download it, and hopefully you will have no problem later when you are going for machine learning. So this is the one that you can go for. Fine. Now, I'm assuming that you will do this later today. You will install your environment, or you install your Python on your machine later today. Now, the question here is, and this is one of the interview questions, pay attention here, don't miss this. When you are downloading this, when I say here, download this Python on my machine, what version or what implementation of Python am I using right now? Please pay attention and answer this question when you are getting in interviews in details. See this point here. This is called as a Python implementation. There are multiple Python implementations. What does it mean here? Actually, when you say Python, Python is a language, and every language has got something called the language specifications, like how to declare the variables, how to declare the functions, how do I pass the parameters to the functions, how do I return a value, how do I use the operators, how do I write the for loop, if loop, so on and so forth. So when you are going for any language, rather every language has got the specifications of how to write the code in that language. Similarly, Python also has provided the language specifications. But the specifications are not enough. We have to have some kind of compilers or linkers, for example, or interpreters to run that particular code written in that language. So in Python, if you want to do this, an implementation is an actual software that you can download and run that reads your Python code, translates it, and execute it according to those rules. So if you want to go for writing a Python code and if you want to execute it, just language specification will tell you how to write the code, but it will not tell you how to execute the code. To execute the code, you need a software, and that's what we actually have downloaded from that python.org here. So what have we downloaded right now? We have downloaded something called as a Python implementation. Which implementation have I downloaded right now? This is called as a C Python, and this is an interview question. What is the C Python? What are the benefits of it? And what exactly does it provide? So pay attention and you will get it. So C Python is implemented in C code. For example, the Python executable that I used right now, if I just go back here and you can see the Python, this is an executable. This executable is written, or this executable is created by using C language, and that's why it is known as C Python. So what you're going to download is called as a C Python, which is a very standard and best library support. So the one that generally will install on your machine is called the C Python. This is used for general case, data science, production, so on and so forth, and it has support for Python 3 as well. So this is the default version. When you are downloading it from python.org, what you download is called as a C Python. More on that in a second, but this is the implementation of Python language in C. Now, our Python is already creating its own version called the PyPy. PyPy is kind of using an R Python. It is a JIT compiled, very fast compared to the C Python, long running pure Python applications, and it has also support for 3.0. We will not use any of them. We are just going to use only C Python, but the coding will not change. It's the way you are going to execute the code. If you are using C Python, the Python is the name of the executable that you are using here, or if you are using Jython, then you are going to use a Jython instead of using a Python. So Jython is an implementation of Python using a Java compiler, means using a Java code. It compiles that code into JVM bytecodes because it is written in Java, and it integrates with the Java. If you are using something like a Java code and if you want to use that Python inside it, you can simply go for Jython. This has support only to 2.7, and that's why it is not preferred in today's world, because today we are using 3.0. 2.x is kind of deprecated. Don't even worry about that right now. Don't even bother about it right now. There's another one, something called an Iron Python, which is developed in C#, which integrates with the C#.NET. You can say it's used on Windows desktop app for the legacy purpose. It has a partial support for Python 3. Then there is something called a Graal Python, which is the modern version of Jython, which is developed in Java. This is the high performance JVM JIT, JVM Java Virtual Machine, and JIT, just it's called as a just-in-time compilation. It's a modern Pyglot, which is like a Java plus Python. It has a support for 3.0. So if you want to go for Jython, don't go for it. Instead, go for GraalPy. Then there is something called a MicroPython, which is developed in C, which is ultra lightweight, and it's used for microcontroller embedded systems. And that's why it is kind of famous on the embedded systems. But it has got a partial version or partial support for Python 3. Actually, these are the reference implementations for you. This is the reference implementation which we are using by default. So if you are downloading Python on your machine, you are downloading C Python on your machine. So remember this point. Now, what is a C Python? This is the question that I'm answering right now. Pay attention. This is one of the most critical questions for Python developer to understand. What is a C Python and how your program compiles? Check this out. So if you are going for C Python, it's a reference implementation of a Python programming language written in a C language. That's why it's called the C Python. The Python's interpreter and compiler is written in C Python. Let me make it simpler for you to understand. Both compiler and interpreters, both of them, interpreter, are written in a C language. So when you are going for a compiler and interpreter, both of them are written in C language. That's why it is called the C Python. It's a reference implementation. It's a default implementation of Python. If you are downloading Python by using python.org/downloads link, by default you're going to download C Python on your machine. It's written in C and serves as the standard interpreter for executing Python code. So if you are downloading it as a standard one, it's a C Python. C Python is an essential component of the broader Python ecosystem, and it provides the core functionality that developers interact with when they are using Python. So most often the one which you are using here is called the C Python. Remember this point. Now what are the key features? This is the reference implementation. Reference means it's the default implementation. So if you want to go for Python, by default it's a C Python. So C Python is an official interpreter for Python and serves as a reference implementation against which other implementations like Jython, IRPython are compared. So this is going to be official interpreter, means you are going to download it from python.org website. So if you are going to download it from python.org, it's by default, it's a reference implementation. You are going to download it called as C Python. It's written in Python. So the core components of C Python, like interpreter, compiler, some other utilities, including blah, 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 they are written in a C, and which means this allows the efficient implementation and integration with other system level operations. That's why it is a faster option available for you. It is interpret language. So despite being written in C, Python itself is an interpret language. More on that in a minute. Just hold on for your question for a couple of more minutes so you can understand what do you mean by interpret plus a compiler. A C Python interprets a high-level Python source code at runtime and converts it into bytecodes, which later will get executed by using a virtual machine. In a minute, I'll explain what's the procedure of it. C API, because C Python provides a C application programming interface, enabling developers to write Python extensions in C, which is usually giving you the performance critical applications of performance critical parts of your application. You remember what I mentioned last time? There are packages available in Python, and there are two packages which are by default every Python developer must know: NumPy and Pandas. Both of them are written in C, and that's why you are going to get the best performance out there. Okay, more on that later when we go for NumPy and Pandas, but both of them are written in C because we are using C Python for the first, for our coding here, and that's the reason why we can use those packages which are developed in C. Wonderful. So you understand that C Python is a reference implementation which is used, I mean, C is used for writing the compiler and interpreter, so you will get a better performance in all the cases. So that's a reference implementation, that's a default implementation available here. Now let us understand, if I go for a very simple hello world application of it, how does it work? Now pay attention to this so you can understand what exactly the way you can write the code. So what I'm going to do right now, I'll go for creating a new directory here called as a Python, and under this Python I'll write the code by using Visual Studio Code. So this is the this is the not ID, but this is the code editor we'll be using here. It's called the Visual Studio Code. You can easily install it. It's a free of cost. You don't have to pay any cost to anyone. Just go to Visual Studio Code, download on Google, and you will get that link directly. So it's called as Visual Studio Code, or you can say code.visualstudio, and you can download it for your other operating systems as well. So if I click on the other platforms, I can download it for Mac, Windows, Linux, so on and so forth. So you have to install it to write the code. It's called the code editor. So what I'm going to write now, I'm going to create a very simple hello world application. I'll call it as hello.py. Extension of a Python application is called as a py, and this is important point for you, because if you do not use a py, your program might not get compiled. That's the reason why you are kind of using the extension as a .py. I want to write a very simple hello world application to print a hello world on console. So this is the way you can do it. Print, and you can say, I'm sorry, hello world, as simple as that. I think we are not in the world anymore. We are in the hell. So I would say hello hell instead of saying hello world, Better to look at the reality right now. So it is like we are in the hell. So this is the one which is going to print a hello hell on the console. Very simple. Abhishek, how would I choose which flavor of Python to install, or how do I check which one do I use on my machine? Can I install same version of C Python on other flavor also? See, C Python is one of the flavors, or it is one of the implementations of Python. If you want to install something other, like for example, if I want to install PyPy, which is a implementation written in Python itself, you can download PyPy and you can install it on your machine along with the C Python. That is very much possible, because both of them are different applications. They do not have any conflicts with each other. But I would not recommend wasting your time doing this stuff, because most of the times, or rather 99% of the times, if you are using Python by default, it's a C Python that you are going to use. So Abhishek, even if you want to do it, it's just for enthusiasm, you can go for it. But otherwise, in real world, we generally will go for C Python. Okay. Shashi, Python, what you asked to download as an interpreter, it does not provide a UI to write the code. Of course not. When you are going to download Python from this website, download C Python from here, by default, you are just going to get the compilers and the interpreters and some other utilities. You never will get any option to write the code. Like, it's not going to provide any UI. It's not going to provide any IDE by default. If you want to go for an IDE, there are multiple options. You can go for something like what is the name? I mean, there are many others. I can go for Anaconda. What's the name of that? Spider. It's called as a Spider for Python download. So it's called the Spider. This is the ID available for you, Spider. So this one here is one of the IDs available, but this is something that you have to download it separately. You can download it for Mac, you can download it for Windows, you can download it for Linux. So this is an IDE. The difference between IDE is like IDE and editor is like, in editor you can write code, but you have to come on the console to execute that code. In IDE, you can write the code, you can compile the code, you can run the code. Everything can be done by using a single window. That's called an IDE. So this is an IDE available for you if you really are interested in that. And if you want to go for editor, which I would prefer you to install on your machine, because it's a very simple and very comparatively it's very fast. So I would go for something like a Visual Studio Code. This is a simple editor for you. So by default, Shashi, you will not get any UI to write the code when you're downloading C Python or you're downloading Python from the python.org version. You have to download it separately. Okay. So when you are downloading this Visual Studio Code, there is an option here that you can install some extensions. So when you install Visual Studio Code on your machine, you search for Python here, and this will give you an extension to provide some more functionalities on Python. Like on my machine, it's already been installed. So you can go for Python from Microsoft and get it installed. So it's already installed on my machine, so I can see uninstall button here. But otherwise, you can click on the install, and this will get installed on your machine. It's called the Python from Microsoft. It provides an extension access to the IntelliSense, debugging, linting, so on and so forth. So you don't have to worry about providing the IntelliSense. It will by default provide the IntelliSense for you if you are using the Visual Studio Code. If you install that package, if you install that plugin here, if you install the extension here. Aditya, so we'll be using an editor and not any IDE henceforth for this course. Yes, I would not recommend to go for any IDE because it will take a lot of your resources. It's not necessary. All the good things about IDEs will be already there in Visual Studio Code. So do not worry about using IDE right now. It will unnecessary wasting of your resources. So better you go for Visual Studio Code. Okay. So that's the one that you should go for. Okay. Now I've written this code hello.py. Now I want to run this code. To run this code, you come on the command prompt and say Python and name of your program. In my case, the name of my program here is hello.py. The moment I execute this, you understand the hello world or hello hell, which I asked Python program to print on console, has printed it on console here, hello hell. Tomorrow, if I want to print hello world again, now if I go back here, save my content, and if I say Python hello.py, you can see the hello world is printed on my console. So precisely, I have written a code in hello.py. I passed that code to the Python and Python has executed that code for me. Now, what has happened behind the scene? This is what I want you to understand, and this is more important for you to digest at this point. And this is something that I'm going to mention today itself, once and for all. So all the programs that we are going to write henceforth, tomorrow onwards, all of them will follow the same philosophy. So understand the philosophy of how the program gets executed in Python. So check this out. It's a 4-step process. Let us see what happens one by one, step by step. So if you are using C Python and you are going to use C Python because you're going to download the Python from python.org, which is a reference implementation or default implementation, as I mentioned. So when you are going to pass that code, like I said, Python hello.py, what happens? Stage number 1. This is where you are going to go for a parser, which is called the lexing and parsing. So let's understand what does it do. When you run your script, CPython first reads your .py file and in the plain stream of characters. So what happens here is, I think step by step, it's better for me to write write or create a diagram here. So this is what we are doing right now. This is my Python code that I've written here. This is hello.py, so this is hello.py. What did I do? I passed it to Python executable. This is the Python. Now what has happened? First thing first, this is the stage 1. What is the stage 1? Stage 1 is, you see here, it is nothing but the parsing, which includes the lexing and parsing. So I'll call it as a parser right now. So that is the parser. So, or parsing I call it as. So this is the parsing. What do you mean by parsing here? So parsing is something like, it is divided into 2 parts. One is called as a lexing, means lexical analyzer it is known as. It uses lexical analyzer to analyze if you are following the rules or not. And then it will parse your code. Parse means it understands what have you written. It's called as a parse. Parsing means reading the code. So it uses 2 things. One is called as a lexical analysis, or lexer it is known as, and syntax analysis, or parser it is known as. So CPython lexers scan your text and breaks it into meaningful token like keywords, so on and so forth, and variable names and so on and so forth. So precisely lexical analyzer will break your code into tokens. Tokens are nothing but the words you can consider. Like for example, in our code, when we have gone for something like the hello world, print hello world, where is it? Print hello world. So this becomes my 1 token. This becomes my another token. Sorry, this becomes my another token. This becomes my another token, so on and so forth. So precisely it is going to create different tokens, and those tokens are used, those tokens are created by using something called as a lexical analyzer, which is known as a lexer. Lexer is lexical analysis. Lexer means you are going to do it word by word or token by token. Then comes the syntax analysis. Whether I am writing the code in a proper format or not, that will be detected by using a syntax. So if I am following the proper syntax or not. For example, if I do not provide this something like the parenthesis, what will happen? If I pass that code here, you see it is giving me an error like, hey, you are missing the parenthesis there. Who gives that missing? Who gives that error, that missing parenthesis here? You see the syntax error. That means the syntax analyzer or parser, it is known as, which gives you that error that you are not following the proper syntax of that language. This is called the syntax analysis. It takes the tokens which created by the lexer and checks if it is following the Python's grammar rule. Like for example, if you are using a function, whether you are using the parenthesis or not, or if you are declaring a variable, it has the initial value or not, so on and so forth. If you forgot the colon, for example, if you are having a mismatched parenthesis, the parser throws a syntax error immediately and your program stops before even it begins. This is what has just happened on our case right now. You see, I got an error, syntax error, that hey, I am missing parenthesis for print. You see, so who has given me that error? This is the syntax analyzer, which is known as the parser in this particular case. If the syntax is correct or you are following the proper syntax, the parser builds a tree called as abstract syntax tree. It's called an AST. Sorry, it is called as an AST, abstract syntax tree. Now understand this point. When you are going for the first stage, output of first stage is called as an AST, abstract syntax tree. That means using the syntax, it builds a tree behind the scene. Not that you have to worry about it. I mean, what is a tree? What does it do? And how does it do that? Don't bother about this. This is going to happen behind the scene. But at least understand the process. This uses a lexical analyzer called as a lexer. I'll mention that also. Lexer. And this is the syntax analyzer called as a parser. I'll mention both of them here. So it uses the lexer and it uses the parser, and then it creates something called as the abstract syntax tree. That abstract syntax tree is the representation of your Python code in terms of a tree. Okay, so this is the job of lexer and the parser. This is the first stage, parsing, it is known as. Once the code successfully get passed, it goes to the second stage where we are going to generate the bytecodes. Now we understand what does it do. The C Python takes the AST and compiles it into something called as a bytecode. Now this is an interview question. What do you mean by bytecode? Let's understand the answer here. A bytecode is a low-level, platform-independent set of instructions. One more time. A bytecode is a low-level, platform-independent set of instructions. Think about it as the assembly instruction for PVM. Now, what is a PVM? I'll mention it in a second. But this is the assembly code for PVM, stands for Python Virtual Machine. We'll talk about it in a second. It is not machine code for your CPU. CPU cannot understand that. Understand this. This is assembly code, but it's not for your CPU code, or it's not your CPU of your machine. This is for PVM. Think of it as a middle ground between your Python code and your computer's hardware, which is kind of the PVM which is used here to interpret your code, which is what the third stage here is. Right now, we are in the second stage. So this AST that we are using right now, this will get parsed to create some, sorry for that. Here it is. So when you are going for this AST, that AST will be passed to create something called as a bytecode. So we can say this is the bytecode generation. So this is called as the bytecode, and this is the bytecode generator we can use here to generate the bytecode. So generator. And this bytecode generator generates something called as the bytecodes. Now, it's not going to generate the bytecodes, rather it's just going to create something called as a .pyc file. Not that you can see here, but this .pyc file contains the bytecodes. So if you look at what's happening right now, once the code gets compiled, it gets converted into AST. The AST will get passed into the bytecodes. The bytecodes are converted, or bytecodes are the ones which are made for the PVM here. These instructions look like the load fast or call a function and so on and so forth, which are nothing but the assembly instructions for your Python virtual machine. By default, C Python does not save this bytecode to a file unless it detects it is having a directory called a pycache, and you have something like this file. This way, your code script, your code run again without changing it. C Python can skip the compilation of this stage next time. What does it mean here is, when you are going to run this code by using Python, all of this stuff will be happening internally. You don't even see that .pyc file. If you want to see that pyc file, check this out. I'm going to go back here. First, let's fix that code. Let's add that parenthesis back. Right now, if I go for something like Python and hello.py, you see I'm not getting any PyC file created. I can see Python minus C, sorry, minus M. We can go for something like the py compile it is known as, and this is going to be my hello.py. If I do this, my code did not run, but I see that I created a directory called as a pycache. And under this pycache, you can see there is a file called as a hello.cpython-311. CPython, because we are downloading the CPython, we already have installed CPython, and 311 is the version, 3.11 is the version, .pyc file. I cannot see the contents of it because it's a binary file. It contains the bytecodes which are going to be executed by using your runtime called as pvm. So this one here is the pyc file. Don't worry about this right now. This is for you to understand what happens behind the scene. You don't have to worry about creating the pyc file, but if the pyc file exists, you can directly execute it without worrying about compiling it again. See this, if I go back here and if I say pyc file underscore, what's the name of that, hello dot blah blah blah, and I can see the output of this file here. So pyc file is a binary file. You can see that it's a binary file. It is a file which is having the bytecodes inside it, and this bytecode will be passed to the next stage. So here in the second stage of compiler, we are going to generate the bytecode. So this is kind of a bytecode generator, or I can call it as a compiler as well. So this is kind of a compiler here. I remember someone was asking the question last time. I forgot the name, but someone was asking the question like how that compiler is working here. This is the answer to your question, whoever asked that question. So this is the compiler, which is like a bytecode generator. It generates the bytecodes for you. What's a bytecode? A bytecode is nothing but the assembly instruction for PVM. This is the third stage we are going to talk about now. In the third stage, we are going to bring the interpreter, which is called as Python virtual machine. PVM it is known as. This is the heart of the CPython. The compiled bytecode is fed to the Python virtual machine, which is actually just a massive loop called as the eval loop. It's called a ceval loop, called a C evaluation, written in C. So what happens here is this pyc file will get loaded into something called as PVM. This is called as a PVM, and the PVM stands for Python virtual machine. This is where your code gets loaded and gets executed here. So load.pyc and execute the code, exec code line by line. So this is the way you can see the Python code will get interpreted. This is the interpreter. Interpreter name is called as PVM. It reads your bytecode instructions one by one in the same order. For each instruction, it performs a C function that executes that operation. So precisely in this case, in case of PVM, for every bytecode, there is a C code that it executes and it will give you output. For example, if the bytecode is a binary op plus, the PVM calls a C function that makes two numbers of the stack, adds them together, and using the CPU's arithmetic logic and pushes them back to the stack. So precisely, this PVM is going to talk to the CPU of your machine. So this is my CPU, and it is going to pass the instruction that CPU can understand. This is the assembly code, and this is the result. So precisely, the PVM reads the code line by line, PVM bytecode line by line, converts it into the form that CPU can understand, and then it gets a result from CPU and pass it back to the user. So that's how the PVM works. Crucially, the PVM code does not translate your code to C. This is a myth. Python code does not get converted to C. It by default gets converted into something that CPU can understand. Your Python code never becomes a .c file. Instead, the C is used to build the engine that drives your Python code forward. So it actually executes the code directly with the help of machine. And that's why your code will never get converted to C. Remember this point. The last one is called as a runtime and the memory management. It is a job of your Python virtual machine itself. While the interpreter runs your bytecode, two critical background processes run constantly running behind the scene. Number one, it's called the global interpreter lock, called the GIL. This is the mutex, or this is like it will make sure no two processes are running the same code at the same time. So this is a mutex or a lock inside CPython that ensures only one thread executes a Python bytecode at a time. It protects the CPython's memory management from crashing, but it also means the CPU heavy multi-threading is limited. So this is one thing which is run inside the PVM by default. It's called the GIL, called as a global interpreter lock. And last one is the garbage collector or the reference counting. Actually, garbage collection means automatic memory management. As your code creates variables, list, objects, so on and so forth, C Python keeps a count of how many references which are pointing to that object. When that count hits 0, C Python immediately frees up memory. It also runs a cyclic garbage collector to clean up the objects for reference counting for the other loops here. More on that later when we go for automatic memory management. I'll talk about it, like what do you mean by reference counting, how does the reference counting work, what do you mean by objects, the underscore ref property. We'll talk about that later. Right now, just understand there are two major components. One is called as the interpretation lock, and the one is called as a garbage collection. So both of them run by default continuously behind the scene. This is the part of PVM itself. I don't have to worry about, I don't have to show this here because that runs inside the Python or inside the PVM automatically. So you started with hello.py right here. You passed it to the Python. Python internally used the lexer and parser to create the abstract syntax tree, it is known as, which will be passed to the compiler, which itself is going to generate the bytecodes, and those bytecodes will be loaded inside the PVM, and PVM converts it into CPU understandable form and then returns the result back to the user. Guys, may I know if you have understood this? This is very important for you to understand once and for all, because all programs in Python follow the same philosophy, same rules. You pass it to the Python, Python does all of that stuff, and then we'll give you the output of it, behind the scene. It's a long process, and you can see that this is how the implementation happens. Okay. Wonderful. Any questions so far from anyone? Any question from anyone? Okay, no question. I hope you understood that, right? This is an important point, and I can bet on this. Many a times people do not know that Python has a Python virtual machine. They generally understand this is always a simple interpreted format, but it's not only interpretation. It does both compilation as well as interpretation. Have you seen that here? This is the interpreter, and this one here is an interpreter. This is the compiler, and this is the interpreter. You see, it has got both compiler and interpreter, and that's why I said earlier it's like both, or it's combination of both compilation plus interpretation. Is it like JVM? Yes, PVM and JVM, both of them are almost similar. There's only one difference. JVM has a JIT, just-in-time compilation. Python doesn't have it. So other than that, JVM and PVM do the similar job. Devansh, that's the question that you have asked. Is the JVM similar to PVM, or PVM, JVM are same? Yes, both of them are working almost 90% similar, 10% there are differences. Major difference, JVM supports just-in-time compilation, PVM does not support just-in-time compilation. Okay. Anyways, so this is what the C Python process here is. It's very simple, it's very straightforward, but at the same time, it's very important for you to understand that. Okay, now let's go back here and understand what is the PVM. This is what I mentioned last time. What's the PVM? It's a Python virtual machine. It is nothing but Python virtual machine. It's a core part, the heart of C Python, the runtime engine that actually executes your Python code. As I mentioned here, the bytecode that you are creating, it will be kind of executed inside the PVM. By the way, I wanted to mention this also, that this is a Python's, the PYC file, it's a Python's bytecode here. How do I know that it's a bytecode? So we can say Python -m, it's called the XDIS. It's like a X disassembler minus this PyCache, and the name of it in my case is hello world blah blah blah. And you can see that this is what it is getting stored inside that PYC file. It's an instruction 0 push null load name, that's print, that's the name of the function, load constant, this is the constant value that I've passed here, hello world, then call that pre-call that function, set to the environment and call that function, something like this, then pop top means I'm done, just remove that on the top, and load constants, that there's nothing to load, there is nothing to return, and your function will stop. Actually, this is called as a bytecode, and this is something that you can understand from this XDIS. This is the module that is used here to find out the disassembly of your Python code. You see, it's called as a Python disassembler, which is used to see the bytecodes inside your PYC file. Okay, just for you to see like what exactly is stored in the PYC file. So that is nothing but the bytecodes. So that bytecode is loaded by something called a bytecode loader here. So this is the part of your PVM. PVM has an architecture which contains 4 major things. One of them is called as a bytecode loader, a runtime engine, the core part which executes your code. Another one is called the memory management. More on that later. It is going to do that garbage collection and reference counting behind the scene. And the object and type system, where it is going to declare the variables with the different data types. More on that later. Again, tomorrow we'll talk more about the data types and other stuff. But right now, for you to understand, these are the main four components of a PVM. It's called as, again, bytecode loader to load the bytecode, runtime engine to execute your code, memory management to manage the memory, and object and type system to declare the variables for a particular data type. This is done. I mean, all of them are done by PVM. This is called the PVM architecture here. So in this particular case, the bytecode interpreter, it's a program that reads and executes a Python bytecode instructions. That's what I said earlier. In C Python, the PVM implements in a C massive loop called the C-val evaluation, as I mentioned, C evaluation it is called as. So PVM's interpreter model, in PVM interpreter's model, each bytecode instructions require multiple C operations. It will do that job internally. No JIT compilation like PyPy or Java. As I mentioned, this is the major difference between JVM and PVM. JVM supports JIT compilation. Here there is no JIT compilation. JIT means just in time compilation. Dynamic typing means that type check happens at the runtime. That's a major difference. Java as a static programming language, static typed programming language. This is dynamically typed programming language. So that's another difference, Devansh, for you. So dynamic typing and static typing. That's another difference that you can find between Java and Python. This is the trade-off. This trade-off, like we are kind of using this little bit slower implementation. It gives us, it gives the Python advantage of portability. That means the same bytecode will run everywhere. Doesn't matter which operating system you are using. As long as you are running Python, Python runtime there or PVM there, it will execute the same bytecode on every operating system out there. Flexibility. Dynamic features like monkey patching, more on that later. Eval, more on that later. Dynamic attribute access, again, more on that later. All of these are advanced topics, which will be discussed later when we go for those advanced points around before the modules and packages. I'll talk about this advanced attributes. Anyways, these are very advanced, most of the times expected from experienced Python developer. So we'll discuss them later in our course. It provides simplicity also, easier to implement and maintain. So that's a kind of you can say advantage of using this PVM architecture here. So PVM is an important, or maybe you can say the core part of your entire Python. Python day-to-day environment. So as I can say here, this is my code, the Python's hello world. You can pass it to the Python, which brings the lexical analyzer called the lexer, syntax analyzer called the parser, creates an abstract syntax tree, which is going to be passed to the compiler, which is going to generate the bytecodes for you, which will be stored in .pyc file. Will not create a file. It will not create a file by default, but it will be kind of using the pyc here, which will be loaded inside the PVM, will be converted into CPU executable format, and then it will give an output to the user. So this is the entire workflow of a Python program. Okay. So I hope you have understood this, and I hope you also have understood what is a Python, what is a PVM. PVM is, again, it's like Python virtual machine, which does the execution of your bytecodes. Okay, fine. So guys, may I know if you have understood all the things that we have discussed today? Today we discussed only the basics of it, or maybe I just introduced like what is a Python, how the Python simple hello world code look like, or how it gets executed by following this entire loop here, so on and so forth. I think we have covered at least the basic part of it. Now, starting from tomorrow, not today, starting from tomorrow, we'll talk about the identifiers, keywords, and so on and so forth, dynamic typing, and so on and so forth. So all of that stuff we'll start covering from tomorrow onwards. So today we talked about the introduction. Tomorrow we start with the foundation. I hope this is okay for all of you. Okay. Fine. Any other questions so far? Any question from your side?
Hello, Amit sir.
Yes, Aditya, go ahead.
So whatever we discussed today, it all is good for our as a foundation. We can
Yes,
say
it's a foundation, correct.
yeah. It may be happening in the background and may not impact what we are doing and when running the code. But this is good for us to have and better for maybe interview purposes or maybe
Correct.
getting the
Mainly it is
things
for
right.
interview purpose. When you're sitting for interviews and if you start showing up all of the scales or if you start discussing all of these points in interview, I can bet on this. Not only interviewer will impress with the knowledge, but also you will get the offer that you are waiting for. So that is something which will make you advanced in Python. Okay, I can tell you that 99% Python developer do not know what happens behind the scene. I mean, they do not even know that there's a PVM available for Python. That's a sad story of Python. Many times people generally learn Python from copy pasting the code here and there, and they say like they know Python, but actually speaking, they do not even know that there's a PVM behind the scene. So if you know this will give you an added advantage when you're sitting for interviews. Okay.
Yes, yes, sure.
Good. Do we get exercises and assignment daily? Not daily. Maybe depending again on the module. So Divansh, it's not like on the daily basis I'm going to provide it. It depends like when the topic is over, I'll provide assignments, and there'll be at least 20 such assignments which are already been designed. So we'll be passing them on as and when the topic is finished. Along with that, I'll be also providing the interview questions, and we'll discuss those interview question answers in the class before we stop for that particular topic. Okay. So that's what we already have kind of promised. No problem. Okay, any other questions so far? Nothing, right?
Yes, Amit,
Yeah,
sir,
go ahead. Sure.
a
Go
quick
ahead.
question. I mean, whatever for today we discussed the topic. For tomorrow we are planning a topic. So, do we have? I mean, do you suggest a method to for us to be more productive tomorrow? So that, I mean, for you can revise today's, or maybe if we can prepare for tomorrow's. So, what it will be better for us to be in a better shape for you.
Absolutely, and that's a good question. In fact, how do we get more productive in this particular course? Now, there are two things I want you to do. Number one, first pay attention, understand the topics, and if you still get some kind of questions in your mind, ask them on the spot. You put them in your chat. I'll try to answer them as and when I find that question is relevant to that topic. I'll answer that question immediately. Or even if I don't answer the question, don't worry. I'll take those questions towards the end of it or when we finish the topic. Because what I've seen here is, many times questions will be asked, but anyways that will be covered in the next topic. So I generally do not answer the question immediately. So it happens. So do not get anxious about it. Don't keep asking the same question again and again. I definitely will. You will get the answer before we call it a day on that particular topic. Okay, that's the first thing. You pay attention in the class, ask the questions, and get the answers immediately on the same topic when you are in the context of that topic. Second thing, and even more important thing, when you are done with the session, the recording will be provided in your student portal. You try watching this session one more time if you have found that topic difficult. More importantly, you start writing the code along with me. And of course, for that, we are already having ton of assignments for you. So you start, solving those assignments on time so that it will be easy for you to get the topic in even a better way. So when you start solving the problems, you will see like sometimes you find, okay, I understood that, but while trying to run the code, I'm facing some real world problems. In that case, Aditya, in that particular case, you will get more hands-on, and probably it will give you more advantage when you start working on the advanced code. Okay, so the other two things you should pay attention to. So all the assignments, when you get them, watch the session again and again if you really want to, but understand the concepts in the class and ask the questions if you are having in the class itself on the same day. So you'll be getting that immediately when you are in the context. Okay, that's good. Wonderful.
Yes, yes, clear, sir.
Thank you for asking the question. Good. Any other questions so far? We'll get the notes as well. Yes. So Shruti, you will not only get the notes at which I'm writing here, I'll be also providing the separate Python notes. I think day after tomorrow you will get, or maybe 2 days after tomorrow you will get it. Don't worry. Arshal, so we do not explicitly need to compile the Python code. We directly run. Yes, we don't have to compile the code. It will be compiled and interpreted automatically. When you pass that to the Python interpreter or Python utility, it will do that both compilation and interpretation behind the scene. You don't have to worry about it. Okay, that's a good question, Harshali. Good. Okay. Any other question? Yes, Sagar, go ahead, please.
Just Amit, this is a general off-topic question I can say.
No
like
problem.
is today's AI world mostly learning any language, like not only Python. If you learn Java or any other language, AI will give the
Cool.
direct code to you, right? So learning this type of courses, how can we focus or how can we practice the things?
I would give double thumbs up to your question actually. And this is not only for Python, this is a very true and this is very important in the today's world. Let me give you a small analogy here. Let's say, I think you can understand, you can relate it when you are kids, Let's imagine that you are in third standard and if your teacher asking you to perform some addition, subtraction, division or multiplication. Now, this can be done by myself, literally by sitting on it and literally by doing it with pen and paper, or I can grab a calculator and start doing it and then putting up the answers there. Which method will be which method will give you more understanding? Using a calculator or doing it yourself? I think answer you know already. I don't have to even answer that question. At the age of third, fourth, fifth, or even let's say 10th, I can say it's not good to use a calculator because there you are learning. Calculator is an aid, that will help you to solve the big or complex problem when you know the basics of it. What I understand here, it's called the vibe coding. Today's world, in today's world, it's very famous. Vibe coding, vibe coding, vibe coding. What does it mean? Without understanding what the code is being written, without understanding the language fundamentals, if you're asking AI to generate the code, at the time of debugging, it will give you a nightmare. And this is what I've already have seen. Many startups who created their applications, they created their MVPs by using AI, literally failed when time came to fix the problems. AI generates the code, understood, but unless you understand what AI is generating, there is no point of using that code. So Sagar, in such way or in this particular world, if you want to be more productive, you have to first understand the basics. Then you go for using AI to generate the code to save the time. Saving time is what you should look for AI as a tool for. It's not the tool to generate the code every single time. It is the only one which is going to save your time. But to save the time, you should understand what is kind of generating. If you don't understand, saving time is making no sense at that time. I hope, Sagar, that gives you the context here, right?
Yeah, got it.
And it's not only for you, it's for everyone who is using AI to generate the code. It's not bad to generate the code using UI, but first understand what that code is. And this is what has happened multiple times. People write the code, but they do not understand what code has been written. So there you first understand the foundations, you write the code on your own and let AI generate the code just to save the time. Saving time is what you are going to achieve, you should achieve by using AI tools. Okay, good. Thanks for asking the question, Sagar. Good. Yes, Abhishek, go ahead.
So just to build a bigger picture for the understanding. So in case of Java, SDK and this JDK and JRE are two different things. So
Correct.
one is essentially have a libraries to write a basic Java code, and other one is basically where the JVM itself is getting installed on your system for running your Java program.
Absolutely.
So likewise, when we are installing Python, and you are interchangeably calling it also utility. So what sort of things are getting installed on your system? So along with just basic Python libraries, or EVM and interpreter, linker, etc. Everything else is also getting installed.
Very good question. In Python, there is no separation of PVM and the interpreter and compiler actually. What happens here is in JVM or in case of Java, it's a two separate packages that you can install, JDK and JRE. JDK will give you the SDK to develop the applications using Java as a language, and JRE will execute the .class file, which are nothing but executables of your Java code. There is no separation in Python. So when you are installing Python, it will install both. It will install interpreter, compiler, or maybe you can say the interpreter itself is nothing but going to run the code by using the PVM. So first thing, when you install Python, it will install the runtime. Runtime means it is nothing but the PVM code that we are looking for. And by default, have you not noticed it? If you look at the way I've created the code, I've executed the code, I use only one command called the Python. So Python code or Python executable itself is acting as an interpreter as well as the compiler. So Python itself, the Python command itself does the compilation by converting your code to the bytecode, and it does execute it by running it inside the PVM. So there is no separation here. So it is going to install both. It's going to install compiler, interpreter, or you can say runtime and a JDK, or in your case SDK, directly when you are installing Python on your machine. Okay.
So, sir, the reason being you calling it Python utility at times, what is the reason for that?
Utility because it does that both job at the same time, right? It's not like we are having a JVM and JDK separated. It does the same job at the same time. That's why we call them utilities. And there are multiple utilities out there. Interpreter itself is one of them, or compile interpreter is one of them. There are other utilities also which are used behind the scene, like AST or lexical analyzer or syntactical analyzer. So all of them are used behind the scenes. So those included together, we call them as Python utilities. Okay.
Okay.
Good. Any task needed for completed today? Yes, Nikhil, it's a good thing. I'm going to pass this on your WhatsApp group. You go through these notes, maybe till the time you are setting up your GitHub repository. But before tomorrow, I think you should go for them. So tomorrow, when we start discussing the next topic, which is dependent on today's topic, you will not get any questions on today's topic. So better you go through the notes today itself when you get a time. Shubham, any history for Python name conversion? It's already been mentioned in the notes also. I'm going to pass them on your WhatsApp group, Python, Shubham. You can definitely go through it. Okay. So probably you will get to understand like what is the version history of it. Chalo. So with that said, I think we'll stop here for today. Again, thank you very much for attending today's session, guys. I hope you must have understood the foundations. Tomorrow we'll start talking about the Python foundations, So this will give an understanding of what is the data type and what data types are available in Python, what even by dynamic typing and all of that stuff. Till then, bye-bye. Have a very good day ahead. Enjoy your day, enjoy your learning, and of course, read these notes before you come for tomorrow. I'm going to pass them on your WhatsApp group. See you tomorrow exactly at 8 o'clock in the morning. Bye-bye. Have a very good day. See you guys.
Bye.
Thank you, sir.
Bye bye.